All right, folks, please find your seats for our first speaker, Luciane Marinoni. We're going to reach here, and we are tabbed in, so.
Just to do this. Hi. Hi, my name is Luciane Marinoni. I am from Brazil and a professor at the University of Paraná State in Curitiba. And I am actually the president of the Brazilian Society of Zoology. And this is why I am here today talking about the collections in Brazil, like in general. First of all, I would like to thank the organization for this meeting and say that it's a pleasure to be here and to be part of it. I would like also to introduce myself as also the curator of the entomological collection, Padre Jesus Santiago Moure in Paraná. And I'm going today then to present the results of the initiatives that the Brazilian Society of Zoology has been participating in benefit of the biological collections in Brazil, with an emphasis on entomological collections. In 2022, the Ministry of Science, Technology and Innovation requested the Brazilian Society of Zoology to coordinate an assessment of Brazil's scientific biological collections. The objective was to provide information on the state of art of Brazilian scientific biological collections for the development of guidelines with recommendations and parameters related to good practice in management, maintenance, and service provisions. The Brazilian Society of Zoology invited them, the Brazilian Society of Microbiology, the Brazilian Botanical Society, and the Brazilian Society of Virology. Working groups were established in each of the areas, botanical, microbiological, and zoological collections, taking into account the representation of taxonomic groups, institutions, and regions of Brazil. These working groups consisted of 50 researchers and curators from all over the country. 3 questionnaires were built. General questions were asked for all 3 areas, but respecting the specific characteristics of each one. Therefore, some questions are unique to each area. And we then did the questionnaire using these following items: identification, characterization, about personal infrastructure, access to the collection, digitization, collection quality, management, and we asked the curators to prioritize the needs of the collections. These are the general results. The questionnaires were sent to 977 collections that we previously surveyed. And we obtained 742 responses in a total of almost 76% of the total number of collections. The total number of institutions with biological collections in Brazil is 208. Now I am going to talk about the zoological collections only, not the microbiological and botany, of course. And the number of collections that answer the questionnaire is 342 of 116 institutions in zoology. These graphs show the number of collections per geographical region in Brazil. In this heat map, we can see there are zoological collections in almost all the states of the country. The only one that there is not collections is Roraima, but They have collections, but they didn't answer the questionnaire. So this is why. So we have collections all over Brazil, in all the states. Actually, we can see that there is a concentration of collections in the southern and southeastern regions. And next, this is an illustration representing taxonomic groups in zoological collections in Brazil. 50% of the collections have chordata and 43 arthropoda, mainly insects. Of the 339 Brazilian zoological collections, 108 contain insects among the deposited material, about 32%. And the south and southeastern also, as the zoological, have the regions in south and southeast as with the largest number of collections. This asymmetry reflects the historical centralization of scientific research in south and southeastern Brazil, in contrast to the immense biological diversity, especially in the north and northeastern regions. These regions, despite concentrating the greatest number or the greatest estimated number of the country, still have less infrastructure and collections. But this is why we did the surveys to now work on the lacks and of the collections in Brazil. Regarding the representation of the orders, Hymenoptera occurs in 71% of the entomological collections, Diptera in 67%, Coleoptera in 62%, Lepidoptera in 58%, and Hemiptera in 54%. About the number of the specimens, 3 collections are the largest, with more than 3 million specimens. Actually, Museum de Zoologia of São Paulo has about 10 million specimens, and Paraná, our collection in Curitiba, the Father Jesus Santiago Moro, has about 7 million. So here we have also collections between 1 million and 2 million that are in the north and the central east of Brazil. About the conclusions of this survey regarding the entomological collections, the infrastructure and preservation conditions of Brazilian entomological collections present a heterogeneous reality, with collections, especially the larger and older ones, exhibiting good infrastructure, while newer and smaller collections show significant deficiencies in fundamental aspects. Although some collections have adequate spaces, digitization equipment, optical instruments, and security systems, a considerable portion lacks specialized rooms for material preparation, environmental control like humidity and temperature, adequate electrical installations, and fire protection systems. This is very concerning about our collections right now. And this is, I guess, it's important to say that most of the collections in Brazil are in universities, public universities. More than 80% of the collections are in the universities. So this is why the infrastructure is not so good. Because the people responsible in Brazil for the universities, they do not know they have these collections over there. So this is very, very concerning. Regarding the representation of the, furthermore, the absence of specific resources for supplies and the lack of systematic preventive maintenance of equipment and are points of concern. In general, the available infrastructure, especially for small and recent collections, is still insufficient to guarantee the ideal preservation of the collection, with many institutions depending on projects of the curators and the researchers. And to meet basic needs, indicating a fragile situation requiring continuous investment and planning. This data shows that despite advances, the long-term preservation of collections depends on more consistent investments in physical and technological infrastructure. That's why we have been working on legislation in Brazil about the collections. And last week, I just participated in the Congress of a law that established the date of September 2nd as the National Day of Awareness for Preservation of Scientific, Cultural, and Historical Collections and Archives in Brazil. And mainly because the September 2nd was the day that the Museu Nacional of Rio de Janeiro got on fire. And we lost the huge collection in insects, mainly arthropods. And that's why you didn't see in the results of the diagnosis of the survey the name of the museum, the Museu Nacional, as one of the biggest collections in Brazil, because there is no more collection of insects. Only the Diptera were because it was not in the main building, survived the tragic accident. And also we have now in the Congress policy, a national policy establishing we have the law that established the National Policy for Scientific Biological Collections, aiming to restrain, to expand, organize, manage, and maintain the holdings of scientific biological collections, as well as to make available the associated data and information that comprise them. So now we are getting there. I guess we are having this conscious about the importance of the collections in Brazil. And we hope that we have this, the recognition of the collections as the most important treasure we have right now on biodiversity in Brazil. And this is, you can go to the QR code over there to see the results of the collection. I'm afraid it's in Portuguese only, but the graphics, I guess the graphs you can understand, of course. And we have all the results here in a BI platform. And you can see as for botanic, microbiology and zoology, and the results, and you can find also the results for the entomological collections per state or per region in Brazil and per taxonomic group. So you can go over there and try to find out whatever you want that I couldn't say here, okay? So thank you very much, and I am free for. I would like to show them. Can you get the books in my backpack, please, Tachi? Yeah. So this is also the result, and it's very important because we did 2 publications with all the results here and telling what's important for collections in Brazil. And this is a guideline for the curators also, just with good practices and telling how to build a collection and how to maintain a collection. And this is also in Portuguese. Mainly, we are trying to translate to English, in Spanish also. And I guess this is going to be, this is already a good resource for the politicians in Brazil. Wherever I go with this one, and I just give and say, okay, this is what you have to do. So this is why I am doing right now. Thank you very much.
I think we are out of time for questions.
Sorry about that.
Oh, good. Okay, and our next presenter is Christopher Marshall.
Hello, everybody. I'm Christopher Marshall. I'm the curator and collection manager for the Oregon State Arthropod Collection, just 90 minutes south of here in Corvallis, Oregon. And today's talk is produced by both myself and Dr. David Maddison, who's the director of the museum, who is sadly collecting beetles in New Zealand right now. My talk has a lot of slides, so I'm going to probably speak pretty quickly. It's not an overly challenging talk to give because I'm really going to give you guys an update on, well, my plan originally was to just show you our newly renovated space. Pretty easy talk. I started looking at slides and pictures and kind of looking back into the history of the collection. And I've been there for 20 years, and I thought it would be kind of better to really talk about a metamorphosis, to also contextualize that a little bit with kind of things that have, how we went from what we had before to where we are today. So we're one of the land-grant institutions that had an entomological collection relatively early in the late 1800s. The collection probably goes back to the 1870s. We're not entirely sure of the details of that early history, but we do know students were studying entomology at that time. This is a photograph from our archive of students studying insects in 1910. I will point out also that OSU had one of the first co-ed programs in the country, and we had men and women graduating from first class at Oregon State University. In the interest of time, I'm going to jump ahead to that day and age of colored photographs. This is Cordley Hall, and in 1957, Cordley Hall was built as a massive building structure on campus. In fact, it was the largest building on campus at the time, and it remains that way by footprint today. It was housed for the agricultural sciences at the university, and in 1957, the insect collection was moved over from Benton Hall, which I showed you in the last picture, to Cordley Hall. It's remained in Cordley Hall since 1957, even through an initial addition in early 1960s. The collection has moved around within the building a little bit since then, and in that time period, the collection was housed in one room on the third floor of Cordley Hall. This is a photograph of today's, what the collection would look like if you came in to visit today. This is our hallway, and virtually, I'm going to show you, it doesn't look anything like what it looked like just a few years ago, and that's why I thought of this as a metamorphosis. But actually, when you start to look back, just like a lot of insect metamorphoses, you can see characteristics that make you realize that it's been developing all along. And in fact, I think that's really important to stay here, is that all of us who are curators and collection managers, we sit in a kind of a time period between the people who went before us and hopefully the people who come after us. And our goal really here, this entire time I've been here, and particularly in this renovation, was to set up the collection so that it would not only be here, but it be thriving 50 years from now. So the talk I'm going to give is basically going to move through the floor plan of the existing facility. I'm going to try and show some of the highlights of the things that changed over time. And just for ease, I'm going to divide those into three general areas: the research and curatorial space and facilities, the support space associated with the collection shown here in red. Oh, sorry, the research and curation is shown in green. The support space, which is shown in red, and the blue space, which is our outreach and engagement areas. The collection occupies an entire wing now on the second floor of the building. And it's you walk down the hallway there in the center, and these rooms are off to the various sides of that corridor. That's the one I showed you a minute ago in the photograph. So I'm going to first part, research and curatorial space. When I first arrived in 2005, the photograph on the left is the room that I arrived to. It was a single large room that housed the entire pin collection, our library resources. It was where we did our curatorial work. We took imaging, we photographed, we did our outreach, and my office was also in that room. I didn't have a photograph of the floor plan, but this was a CAD version I did in 2005 when I was trying to convince the department we could better use the space for different cabinets, and I was preparing to submit our first NSF grant. So you can see it on the right here. I took the office space, which was originally supposed to be the curatorial's office, and I converted it to a library and moved my office out front in front of the front door so that we would have greater visibility and I could be more welcoming to the collection for people who were coming in. That turned out to be a mistake, but I also took some of those old desks and I sought to get money from the university to put in actual lab benches because I knew that the collection needed to have actual respectable research space to work with the material. And I continued to invest efforts in trying to make sure that the collection could not only be a place worthy of housing the collection, but more importantly, it would support a research community and visitor community who wanted to work with the collection. I think that's really critical. Today, in the newly renovated space, we have a designated curatorial space, which is that green area to the upper right in the bottom corner there. It's fully separated from the rest of the repository by doors, and it has space for 4 to 6 researchers. We have the imaging system in there and basic laboratory gear for doing dissections and basic specimen handling. We also have a brand new down the hall museomics lab, which is a functional museum dedicated space for extracting DNA out of museum specimens solely. Again, here on the left-hand side is actually starting to talk about the repository, and this is on the left. Those are that's the hatch beetle collection when I arrived, and trying to get the hatch beetle collection into the collection required our first big NSF grant, which required replacing, or the opportunity, I should say, it provided an opportunity to begin replacing the old California Academy cabinets with the Delta cabinets you see on the right. The other thing I realized from my CAD drawing was the only way I was going to expand the collection at that time, because we had no more floor space, was to go up. So we have custom built cabinets that unfortunately I'm the only one who can reach the top shelf. So we have step stools for people to reach up higher. Right after that, we also had our first successful public campaign to raise money to buy cabinets, and we were able to buy even more of these standard cabinets to fill the room. And at that point in time, we had about 60% of the collection housed in modern cabinets, and we were rapidly pissing off campus surplus by sending them old cabinets that they couldn't get rid of. And today, with our most recent round of NSF funding associated with this renovation that we had in the building, we were finally able to get compactors into this room and replace the last of the Cal Academy cabinets that we had originally. So now the entire collection is housed in compactorized stainless steel Delta design cabinets in a designated repository area. This is what it looks like. So in addition to the curatorial space that I showed you a minute ago, it provides this really long, narrow, thin area where you can sort out all the drawers. So we can fit a ton of drawers there. This is me and Tim McNary sorting out our grasshopper collection just last year. And so we could lay out all the unsorted material, all the sorted material, and really get a handle on it. Now I'm going to talk a little bit about the collection support space. I'm not going to mention the first room up on the upper left side there. That's my office. So now I have an office outside of the collection, but nearby, so I can see when people are coming and going from the collection, but I don't have to have them standing right over my desk. But the other 2 spaces in the collection are really about support space. In the old Cordley Hall room, this is a picture of our climate control. These are the windows that were behind the cabinets in the old Cordley space. That was our climate control. We had single pane glass windows from the 1950s covered in sorts of grime. And it got so hot in the summertime with the southwestern sun blaring down in there that students decided to cover the windows with aluminum foil. So you can see that it's peeling off there and the things. We would get regularly to a temperature of 104 in the collection, which was not only unworkable for ourselves and for volunteers who were working in the collection, but it was killer for the dermestid activity in the collection. So we were constantly running from cabinet to cabinet, checking for dermestid outbreaks and using a small upright -20 freezer to freeze those drawers and keep the collection at bay from the dermestids that were constantly coming in the windows, because you had to open the windows to basically stay cool. Today, we have a walk-in freezer, thanks to inspiration from the Smithsonian for that, because we were the only walk-in freezer allowed in the building, and it's because I basically threw a giant fit that I was going to stop using the -20 freezer upright. So we now have a huge walk-in freezer, and in order to freeze our entire collection quickly, I decided to take to something I did when I was catering, and we bought a bunch of catering baking racks, and they do great for holding Cal Academy drawers, and we can put in 2 cabinets worth of drawers, 120 drawers at a time for 48 hours to freeze for dermestids. I do have there needs to be some updates to those carts because the wheels don't do well at -20, but there is grease I need to get for those wheels to make them a little better. In addition to this, we have now a fire suppression system, the first one we've had in a long time. And in fact, it's a powder-based fire suppression system that's limited to the collection itself, and a humidity-controlled actual climate control. So it's actually pleasant to work in the collection and better for the collection material. And I want to make sure I'm doing okay for time. Yeah. So now I'm going to talk about kind of the most visible aspect of the update, which is the collection display and outreach space. Originally in our collection, you can see me here giving a tour to the collection in the upper two photographs. And I want to highlight that because our room was all in one space, you kind of had to choose what you were doing. Were you going to be doing a tour that afternoon? Were you going to be having people work in the collection? Were we going to be curating in the collections? It was one space and they didn't really blend together very well. We did it. We made it work and we did a lot of tours anyhow, but we never could really make that function very well. Today, when we worked with the architects on thinking about the floor plan, I really wanted a space where we could move people through the collection, actually have them see the collection without disturbing people doing work in the collection. So that's why we have that separate curatorial space in the back corner. People can enter into a reception area shown here in the photograph. We can greet them. They can leave food items or sticky drinks and things like that in that room. In fact, we even have coffee systems set up in there so that people can actually enjoy the space, but then they can move into the repository directly from that room without ever bothering curators or students who are working with the collection in the back room. Those doors are totally separate, and then they can move back out in the hallway. I also realized all of a sudden when we got the new space, I hadn't kind of really recognized it when we first moved in, but the hallway itself is like a little mini museum that inserts itself into the collection space itself. And we've done everything we can to maximize the experience of person who's walking down the collection in case we don't have the capacity to bring them into the collection. So we have gallery space on the right-hand side. That's an exhibit of butterfly photographs from a local butterfly person. We have cases outside in the hallway that people can engage with. And then we have these things we call museum portals. They are the classic windows into the aquarium that is the curation space. We actually love having that. And actually some of our students love working in that space. And there's plenty of spaces to work and hide if you don't like being in that space. But we love it because it showcases to people who are walking by how large the collection is, how modern it is, and activity taking place in the collection. Here we go. This is just another picture of that. The display cases, the wall-mounted display, and museum portals on your left with a series of displays, and then a banner that the university made for us. My office is right outside of this portal, so I see people all the time. Now campus students, campus tours come by all the time in the collection to see the material, and they talk about the entomology program or the biology program. And students work with the collection just to get information about courses and other things taking place at university. I've designed these exhibits really carefully, so all of us have these spectacular bugs we can put in the display case and get people to gawk. But our displays really highlight things we do in the collection because there's administrators and other people who are visiting, and that helps us promote what we actually do, not what we have in the holding. So here's our local butterfly, but we also have exhibits about conservation and the way in which the museum staff is actually helping with conservation efforts. We also have things like diagnostic things we have helped with and participated on. These are those Asian giant hornets that were first found in Bellingham, local story with a diorama. And then we also still engage in outreach. This is from our Night of the Museum exhibit tours. That's me doing as a ghostly curator. This was started about 8 years ago. We had about 45 people. 2 weeks ago, we did it for the 7th or 8th time, I think. And we had over 700 people come through the collection. And in combination with the other collections on campus. This is showing that a little bit. We also have a live insect display that we're working on with the OSU Bug Club, and that's on the hallway, far away from the collection itself, but allows people to engage at some of the live insects. Last talk, I'm just going to have a few slides here because all of this development and this change happened dramatically in 2000 when the building that Quarterly Hall was remodeled. We went from the southwest 4th floor corner to the 2nd floor where we could get those compactors. And it was a lot of work. So this is me packing up the collection in 2020 in the heat of the summer. Again, I told you we had no climate control. And it was COVID. So everything was masked, and we had a student crew that had to stay 6 feet apart the entire time we packed up all those pallets. The pallets were moved by a moving company off campus by 3 miles, where they sat for a year and a half well, after we unloaded them in that facility. So we could use the collection for a year and a half. And then in 2002, I packed up the entire collection again and moved it back onto campus into our new space. Thankfully, I had volunteers. This is Paul Hammond, some of you may know him, and John Shepard, two of our Lepidopterists, and they actually were so generous to help me put away those drawers again for the second time. And we finally got back in our home sometime in 2022 and 2023. Lastly, I'll just point out that we've always had an alcohol collection, a wet collection that's in a separate room, and we were able to actually, with some extra money from the renovation, they were looking for places to spend it, so we were able to buy compactors for our wet collection too. They just moved in earlier this last year, so they're not accessible yet, but I will be working on that the next year to make sure the alcohol collection is at the same level of curation as the upper. So in hindsight, you look back and you can't see the difference between the leaking roof ceiling collection that we were kind of trying to do everything we could in, which sometimes felt like a garage and sometimes felt like a world-class museum, to the world-class facility that we are today. And I hope this brings hope to some of the new people who are just joining the work of curation at small collections in universities, just to keep up the work and keep pushing at every opportunity you can to get grant money, get activity, get philanthropy going, because you can transform your collection from where it is to something that really speaks to the collection that you have, that the specimens that are in it. These are just some of the projects that we had funded that help with some of the funding for some of these things, but more importantly, help to raise our stature with the administration so that we were well poised when they were looking for renovations to invest in the collection. And lastly, I look back, this is a PowerPoint presentation slide I gave to my own department when I first was hired on agendas. I was looking at old pictures and I found it. And I look back, I'd kind of forgotten about it, but it speaks pretty much true to what I've been doing for the last 20 years, is always hunting for money, always hunting for partners, always trying to build community in the collection. And I think it's coming to fruition. So with that, thank you. And hopefully some of you will come and visit and see it in person. So questions? Is that okay?
All right.
Sorry.
Well, no time for questions. All right, and our next speaker is István Mikó on the UNH Natural History Collection Complex 2.0.
Oh, so I gave a talk here in 2019. It was the last pre-COVID ECN. You don't remember of that talk, so the introduction, 1/3 of the presentation will be exactly the same that I gave at that time. Oh, perfect. So New Hampshire is not the largest state in the US. When I moved there, I don't know if I understood exactly that New England is not one state. So, but despite the fact that it's actually, California is 17 times as big as New Hampshire, it is surprisingly rich in habitat types. And that's why it's actually also surprisingly rich in insect fauna. I give you one example. We have exactly 603 cicadellid leafhopper species reported from New Hampshire, making New Hampshire the richest state in the US in terms of cicadellid diversity. Dimitri might say it's differently, but it sounds really good. Actually, we have more cicadellid species than Canada. The cool part is that I think 60-70% of these species are from Don Chandler's backyard. So it kind of like tells you how much do we know about cicadellid. So from now on, you all became cicadellid taxonomists, and I will be the only one working on Seraphinoidea, which is kind of like the fact today. So we have actually a university, New Hampshire, University of New Hampshire, and we have a nature history collection complex. We had this in 2018 too. It was a herbarium in the basement and the insect collection on the second floor. That's kind of like tells you the importance of the two collections. No, not kidding. These were really great places, renovated in mid 80s, I think. But there was a problem with these multiple problems with these places, that the building Spalding Hall was not perfectly well equipped for keeping collections. We had climate issues, not as bad as, you know, you heard from the previous collection, because in New Hampshire, we have an awesome climate that at least part of the year, we don't have to worry about climate. But we had serious issues with the windows, for instance. We had leaks in the windows, etc. The herbarium, the Albion Hodgkin herbarium at that time in 2018 was led by Chris Nifus, who is still there actually. It's a very decent herbarium and very important herbarium in the US, 235,000 specimens. I think it's the most famous about its marine collection. It also has 102 nomenclatural type specimens. Well, the insect collection is also very substantial, thanks to mostly Don Chandler's crazy industrial insect collecting he did in the last 30 years in New Hampshire. 700,000 specimens. By the way, when Don arrived to New Hampshire in 1986, we had 250,000. So, and most of the specimens were actually mounted and handled by him. We have also his Pselaphinae and Anticidae collections that makes our collection very valuable. We have over 5,000 secondary type specimens. So that's the insect collection. And if I give you an overview from 2018, so they had 3 curators, 0 square feet public space. Number of digitized specimens were awesome for the herbarium. Almost like 94% was digitized. The insect collection, I wouldn't say that. So only 17,000 specimens were digitized. The capacity was full. So the herbarium was fully full. The insect collection was also pretty full. So there was, no way we can grow out. That's the second important thing when we talk about why Spalding Hall is not really, or was not really good for keeping these collections. And the cabinets, the quality of the cabinets, when you open an insect cabinet and you pull your finger and you get this nice powdery brownish, actually it doesn't smell anything. But anyway, in the digitized images, the herbarium had all of the specimens that were digitized, actually imaged too, because that's an image-based digitization. And the insect collection had 4 B specimens imaged. So, and, in 2018, they decided to renovate Spalding Hall. It's just like Chris mentioned that we, renovate a building, that's a good opportunity to do something with the nature history collections. And they came up with this really amazing, at the time, I'm sure not AI generated visual images that this is how the space will look like. And look, they even showed that we will have an insect collection, a new herbarium space, compactors, and then we will have an open classroom in the middle. Everything is open concept. So that was the time when actually I arrived to New Hampshire. And so let's just now I give you a brief overview what happened between 2018 and today. So there's like 3 sections here I would like to talk about. First is personal movement. There were people moving in and out. There was digitization, and I would focus on projects that we used or we applied, we hired, and we we worked with undergraduate students. And then finally, I would also like to talk about the infrastructural movement that we did in the last 5-6 years. Personal movement, very brief. 2 collections managers were hired. I was in 2018. That's why I gave the talk in 2019. And Erin Siegel from University of Lafayette, she was a professor there, but she decided to come actually and be collections manager. That kind of like tells you how the prestige of, I think, collections manager positions is changing, I think, or have been changing in the last few years. And then we lost 2 curators because Don Chandler got retired. He just said, okay, I'm starting the second career. Since that, I think he spent more time with his Beetles than ever. And Sondra Rehan, our B professor, left to York University. So in the last 5 years, we were, I think, okay with getting NSF funded grants. First, we got a grant on as part of the terrestrial parasite tracker. Thank you so much, Jen Zaspel. Then we also got a LabNet PEN grant, and also we were part of the Big B project and 1 herbarium digitization grant. So these grants helped us, what the herbarium did, if we talk about digitization workflows, they just kept doing what they did before with this awesome light box and imaged even more plant specimens. In our case, we had to develop some digitization workflows. The reason of that is perhaps also that why was it challenging that we tend to use digitization methods that are not often used in specimen or insect digitization. So, of course, with Jens Aswell, we applied slide scanning. We got Mark's macropod system that we use to digitize our tabanid and bee specimens. We developed the digitization workflow that I'm going to talk about a bit later. It's an iPhone-based digitization workflow where students can use their own iPhones. And then it's also linked to the TaxonWorks content management system. We applied confocal laser microscopy for digitizing slide specimens. It's not often used because Canada balsam has a very strong autofluorescence, but if you go really far red, then you can still manage to image slide specimens, and you get 3D data from specimens that have been slide mounted, I don't know, 100 years ago. It's a pretty good feeling. We also used micro CT images in collaboration with the Karlsruhe Institute of Technology. That was part of the Big B project. We then later with students reconstructed the male genitalia and terminalia of certain underlying bees. And of course, we did 3D reconstruction using these specimens and also 3D printing. That's something, and it's not part, of course, of the digitization project, but it's certainly good that you can show actually what you are working on, like blown up in a bigger size. So we use TaxonWorks throughout, and it's really I really like this system because the training for students training is really decreased with TaxonWorks, especially if you want to see our students. It's really their product. They developed a digitization workflow and they created this YouTube video. I think it's 2.5 minutes long. You can get it when you go to this QR code. It's really amazing. So students are coming, they're watching the video, they're teaching each other, and TaxonWorks also allows students to step inside, being involved inside digitization with absolute different skill and interest levels. If there is a student who really like to make images with a cell phone, a student, of course, after training how to handle drawers and specimens, they really can stay on that level. But if they want to go, it's really well structured, this TaxonWorks system. So we're really happy about that. And our data are available through multiple repositories like SCAN, the Macroalgal Herbarium portal, of course, GBIF, and we have a TaxonWorks-based Taxon Pages website. It's still under development, but you can already access our specimens. The very good thing with this, and thanks to NSF and all the people who let us to do this, is that you can really involve and bring in lots of undergrads, right? So in the last 6-7 years, we had 62 undergraduates working for UNH, and many of these undergraduate students, they were actually ended up doing independent studies with us. We have these 795 classes. So 23 undergraduate students, while they were working 10 hours a week, 5 hours a week on the digitization project, they actually were doing research with us. And, these are some of the posters. I'm an insect morphologist, so it's really easy to come up with small projects for students. Here's a new species, there is a new mussel, etc., which students really enjoy. And so, again, that's one of the, to me at least, is one of the great advantage of being involved in this digitization project. So actually, I have two students here, Pazo and Diana. Pazo is going to give his talk about Nasonia wasps and sex-specific trade-offs of Nasonia wasps tomorrow. And Diana is going to give a talk about Beus. Everyone knows, of course, Beus, the small spider parasitoid, that females, even though being wingless, they still retain the indirect flight muscles because they are reusing that for jumping. So, meanwhile, COVID, now I'm not going to talk about COVID, it was a long time ago, but meanwhile, we did this digitization and really have awesome time with our undergraduate students. We were actually moving, right? So first of all, we had to move out in 2022. We have to move out from Spalding to another building that's named Putnam until they renovate Spalding. Now, Putnam was much smaller than Spalding, so we ended up removing all of the empty insect drawers, put on the shelves, and just, try to save somehow the space. But students were kept, they kept working even in Putnam. You see in the back, there are these two pipes because we had to have constant air conditioning because they were not able to turn down the heating, so it was overheated. But finally, actually, we were really well controlled on an American way, right? So you run the run the heating and you air condition. I think that's really something that people are looking for. Some students were really happy about Putnam, like Julia really liked to be in Putnam. Well, Erin, the collections manager of the herbarium, she was not that impressed. Especially when we moved to Putnam, again, it's not the ideal building, even worse than Spalding. We got the news that because of COVID, the renovation budget went just up, skyrocketing. So it's possible that we are actually not even going back to Spalding, or if we go back to Spalding, the university cannot support even the compactor system. So what will happen with us? And then, bang, we got a really pretty big, very decent sized collections improvement grant. And that's kind of like also, convince the university that, hey, guys, we have to finish really the renovation. And they did finish the renovation. They were not able to replace the windows on Spalding, but they actually finished the insect collection and the herbarium. So when you come to the old part of Spalding, it still looks like 30 years ago. Inside, everything is renovated. And of course, we got this awesome new place. Moving back to Spalding, when we moved out, we hired movers. But then when we moved back, we just talked with Don Chandler and said we would move back because, the movers actually dropped 2 drawers. So we're kind of pissed off. So we rented these U-Haul trucks with Don. And yeah, if you have Cornell drawers and U-Haul trucks, this 2,800 drawers fit into 3 loads of U-Haul trucks, which is pretty amazing, actually. And then when we wanted to move in, it turned out that the cabinets didn't arrive yet. So we had to put the specimens, all of the collection in a separate room already in the new building, which actually made an opportunity to invite the faculty and say, hey, look at that. This is the collection we have, which again, so, this temporary logistical nightmare, we got this engagement opportunity, and actually faculty really acknowledged this. And then we finally moved in. Don is super happy. He can lift 7 drawers, right? This guy is strong. But he said it's because he's from California. Anyway, this is how it looked like, and this is how it looks like. Chris is able to reach the top because perhaps he's much higher than me. I cannot reach the top of our cabinets because we wanted to really maximize the size. We have basically 40% increase in the insect collection. These are some numbers. I don't think I have actually time to go through everything. If you just check out how many number of images we have now, it's 86,000, over 86,000 comparing to the 4 that we had before. What we also did, of course, I didn't mention that, is an awesome classroom and a public space where we can actually receive classes, high school classes we just had. And people from all over the university. Thanks, questions, we don't have time.
All right, thank you. And now we have a short 5-minute break. And a great thing, check out the silent auction. Get those bids in. All right, folks, let's get back to our seats. Once again, we are about to start, so please take your seats. All right, very excited for our next speaker, Wendy Moore with Back to the Future. Great Scott.
Thank you, and thanks for accepting my application to speak to you guys today. I'm really excited to be here. I'm from Tucson, Arizona, at the University of Arizona. I'm the insect collection curator there. It's a 0.2 FTE position, and I work in that collection along with a 0.5 FTE collection manager, who you probably all know. I'm going to show a picture of him soon, Gene Hall. So I'm going to take you on a quick visit to our collection, and then I'm going to do something completely different. So we're located in the Forbes building, which is really behooves us because the Forbes building is located right in the center of the University of Arizona's campus. And that allows us to have this very vital collection with a lot of students and faculty engaged and a high visibility. We're right next to the main department office. Tucson itself is located more or less in the middle of the Madrean Sky Island archipelago. And you can see one of these mountains just to the north of the city, the Santa Catalina Mountains. And basically these mountains soar from the desert, where you've got saguaro cactus, all the way up to pine forests at the top. And there's about 65 of these, half north of the border, half south of the border of Mexico. And this creates a very rich habitat for arthropods. And so we are located right in the heart of one of the UN recognized biodiversity hotspots. So similar to Chris, looking back, here's our Forbes building. It was built in 1915. And even before this building was built, where we are right now, the entomologists were starting to collect insects in Arizona, but they weren't really focused on that biodiversity that I was talking about. We're also a land-grant university, and they were focused mostly on agricultural pests. So here is our first insect collection. It's probably not the first. This is a snapshot of it in 1940, and it was in a group of Schmidt boxes. When I was hired, it had grown to 2 million specimens in the pin collection. And the strength of our collection is that it was really worked on by really active curators and collection managers. And they would host visits from people all around the world to come see this biodiversity hotspot and actively download their brains onto our specimens. So we've got about 85% of our specimens identified to the species level, which is pretty remarkable. At that time, they were housed in these avocado-colored homemade insect cabinets with homemade drawers that were not very resilient to dermestids, which is a big problem for us. And so we have worked hard to change that, and we have modernized our collection and moved the pin collection into compactors and modern Cornell-sized drawers with unit trays. We established an endowed visiting researcher program that's still active, so we can pay to cover expenses of visitors to come and work in our collection. We established a specimen level database that was first known as SCAN, and now we've moved it to Ecdysis. And with additional support from the Schiller Foundation, we built a DNA extraction lab inside the footprint of the museum itself and established an endowment that's a curatorial operations endowment that covers non-salary expenses for the collection. So that's good. Just recently, we actually did a whole new renovation, and we've I think it's about a 50% addition of drawer space that's allowed us to really get a bunch of new accessions that are very targeted toward our mission, which I'll tell you in a sec. So those include the Robert L. Minkley collection of native bees that we got from the University of Rochester, well, really from Bob Minkley, the Ian Watkinson collection of moths from Yuma, the Pat Sullivan collection. I don't know if you've been to the infestation. A lot of people come to Arizona in August to see his amazing collection. We didn't get his entire collection, but we did ask for the Ramsey Canyon collection, which is a 20-year survey. This man lived right in that canyon, and so it's a really beautiful time capsule of a very biodiverse place. And then also Mike Irwin's collection, which he's an extensive Malays trap collector, and we have a lot of his collection. So that's it for the collection. I'm not going to show you all the cool stuff we've got, like the space and all that work we've done. Poop, I'm not going to talk about it. I want to talk about it. I do, but I'm not. I'm going to talk about something else. So I don't know how many of you know Matt Buffington. He's probably here, maybe here. He came and visited me and he said, Wendy, you should go to ECN and tell him what you're doing at the U of A. So I said, oh, okay, I'll just do it. So with his encouragement, I applied to give this talk. And I basically want to talk to you about what I, as a curator, have decided to do, how I wanted to put my energy toward building the collection now that we have it secured. And again, we want to, the mission of our collection is to have every specimen, or no, sorry, a specimen of every species that's on that map, if we could. Like that's our, like we're a regional collection. We're not a global collection. We're pretty small. And one of the things that inspired my decision, two things inspired my decision. One is Gene Hall. So he is a half-time collection manager. He's also a half-time insect diagnostician. And he basically has a database in his brain of most all of the species of insects in the Sonoran Desert region. Like no one I know. He's worked in that collection for many, many years as a volunteer, but now also as a paid staff. So I wonder when I look at that and I think about the fact, like, what if I lost Gene? You know, what would we do? How would we identify all of these insects? And it's not just Gene, right? It's also a silent extinction of taxonomists writ large, not in this room. Here we have people who are really engaged with their organisms. They know them, they can put names on them. They've done all that hard work. But as most of you know, that is not a really, really, really thriving field for the future. And so not only that, but we're losing our biodiversity. So all of that together inspired me to try to establish an integrated specimen-based identification resource for our collection, for our region. And so a lot like the Smithsonian's curation assessment method of the McGinley system, which a lot of us use to assess how well we're doing with our curation. In a way, I think about what I decided to do, at least temporarily, as another level of that. And here are two examples. And so these are two specimens from our collection that have our unique specimen identifier numbers, so UIC numbers, but they also have these bold numbers. These are barcode index numbers. Now, don't go to sleep. Don't go to sleep. Don't lose. I don't want to lose you. So I'm a molecular phylogeneticist, but I also deeply care about collections. And so what I want to try to do is convince you that barcoding your insect collection isn't necessarily about barcoding, increasing the barcode of life database, but increasing the value of your collection. Okay, so this is what we're doing. We're doing some barcoding, but we're incorporating our barcoded vouchers into the corpus of the collection itself. So we have barcoded header cards, if we've barcoded that species. And on the barcoded header cards, there is the bin number, the barcode index number, which I'll tell you about in a second. And then also a GR code that will take you directly to the page on the Barcode of Life website that is specific for that bin number. So as your work, and then we incorporate into the same unit tray all the other specimens that morphologically we predict would be in that bin. So each specimen that's been barcoded has its own label, and if it hasn't been barcoded, it's in the unit tray, but it doesn't have that barcoded specimen. So this is not easy. It's not hard, actually. It's just a lot of work. And I'm not sure that I would continue to do it if there weren't for a amazing set of coincidences that happened. So I just want to give you a little step back on how I got there to begin with. After we did our renovations, I wanted to figure out how to get students in the collection and teach them some advanced biotechnology skills at the same time. So I developed a bunch of cures or course-based undergraduate research experiences where we would bring students in and they would adopt an insect, and we would take a tarsus or a leg, depending on the size, and DNA barcode it. So if you don't know what that is, I'm going to show you in a second. But then the second part, okay, 2 minutes? 3 minutes. Okay. Oh, okay. Then COVID happened. And I had to think to myself, how am I going to be active during COVID? Now, luckily, I live in a place where there's a lot of biodiversity and there's a lot of retired systematists, and they didn't have a lot going on. And so I took advantage of that and a vertically integrated project initiative at the University of Arizona. That's kind of the middle. The future is that I have a new volunteer curatorial assistant who's retired from Notre Dame, and she's all into this, and she's going to take it over for me because it's a lot too much for me to handle. So that's the pregnant pause and the warning. Okay, so this whole thing needs collaborations. I'm going to fly through this. So this is, if you don't know what a barcode is, how do you identify an insect specimen using a barcode? You basically use what they've developed with the Barcode of Life database system. You select a standard region of the genome, like the CO1 gene. You build a reference library of those genes from expertly identified specimens. You create algorithms that cluster them together, and that's based on the sequence itself, and that's what a barcode index number is, a bin. And then you can compare an unknown to that reference library. So if you're out, you have an insect, you collect it, or you have one in the collection that you don't know what it is, if you can barcode it, then you can look for its closest match, blast it to the bold database, and get 100% or 92% sequence similarity and have a good idea of what it is to the species or the genus level. I mean, if it's a tiny little insect that you don't have expertise in, that's a far way to go. So the Barcode of Life data system is so much, I'm so impressed with it because it has many ways of quality control. So you have to have a photo of a specimen, you have to have a georeference of the specimen, you have to have the original chromatogram sequences, the original data, and most importantly to me, you have to have a specimen vouchered in a museum. So that specimen is the gold. That's the gold standard. Not the barcode on the bold database, but one specimen that's been sequenced compared to all the other sequences in that reference library and has been given a bin. So here's just an example of one of those bins. Both are unknown and are known in the bold database go to the same bin. It's pretty much based on this underlying premise that there's going to be more between species variation and genetic distance than there is within a species. And they can be used as a proxy for let's not say a species name, a lineage, a group. a mitochondrial type, whatever. So it's just a powerful tool. It's a glass half full, half empty. Many bins are not associated with, or they're associated with many different species, so that's not perfect. Some don't have any expertly identified specimens in them yet, but they are all deposited, the specimens are deposited in separate museums. Okay, I'm going to have to really skip through this a lot. So let me just say we did this. We've done about 4,000 specimens so far. We've done it with collaborations, all systematists. They donated 95 specimens identified to the species level from the Sonoran Desert region. But we also took the DNA Barcode's old DNA bus where they would travel around when they first started and they would visit museum collections and barcode the specimens. That sent them to Yuma and to get specimens from Ian Watkinson. And all of those are coming to us. Ian said, hey, why don't you go to the community college next door, get more of those, because when they were here barcoding all of my great moths, they also just did all of those. So we got 1,700 orphan voucher collections, and we are incorporating them into the collection. So just like a species name, we'll link members of that species to other museums, specimens in other museums in that species, and the literature that contains almost everything we know about that species. The bin is going to link specimens in that bin to other museums and also to any DNA-based biotic surveys and inventories that come down the road, and maybe even environmental DNA, which uses the same region of the gene. Okay, so here's some examples that I don't have time to tell you about. I don't have time to pause. I'll just say, if you're interested in all of this, talk to me later. Ask me about the Visiting Arthropod Systematist program. This is all dependent upon Nora and also Guelph contacting me, Paul Hubert contacting me and saying that he'll pay for it. So there you go. When you think about it, if this makes sense to you, we'll share everything that we're doing so that you can do it too. And I want to make acknowledgements, especially to a wonderful undergraduate, Isabella Hurst, who's here with me. If you want to talk to her about it, she's really knowledgeable, and all of our collaborators. No time for questions.
All right, thank you, Wendy. And our next presenters are Alessandra Pandolfi and Davide Del Paz.
Thank you. Hello, everyone. Today we are both from the University of Central Florida in Orlando, and today we will present and we will talk about the university collection and how we could improve its visibility. So the collection was founded in 1990, and at the beginning was just a teaching collection. The founder was Stuart Fullerton. Sorry, you can see that. Okay. And at the beginning, it was just a teaching collection. And the focus was mainly on arthropods from the UCF campus in the Central Florida area. In 1993, the collection increased in size, and they decided to dedicate a room to the collection. That's when the collection took the name the Back Closet. In 1997, since the collection became bigger and there were around 148,000 specimens, the university decided to dedicate a new room, a bigger room. And that's when the collection took the name of the University of Central Florida Collection of Arthropods. And in that room, there was an area dedicated for the entomological collection. And on the back of the room, there were also other zoological teaching collections. In 2001, the collection reached 290,000 specimens, and it kept growing. In 2010, Dr. Song became curator of the collection. I think he's here. He was here before. And he did an amazing job during that time. And during that time, the collection gained a new room, where it was also possible to create an area where there was a camera system where the students could take pictures of the specimens. Since the collection grew and there was need for help in the collection, in 2012, the university decided to hire a full-time collection manager, Sean Kelly. And when Dr. Song left UCF, Dr. Sharanowski was hired as professor and as curator of the collection. Today, the collection has 575 plus specimens. So during these years, there was like the need of creating a database. So at the beginning in 1997, the first database was made using FileMaker Pro. And there was around 150,000 specimens recorded in this database. Each specimen had a unique identifier, but this database, there was a problem. It was not available online. Luckily, in 2005, there has been an upgrade of this software, and the database was available online. There was some search capacity via this instant web publishing. And the collection was, the entire pin collection was database. The most of the job was done by Sean back then. And he was still a student back then. This database had a few limitations though. FileMaker was only available for a very simple search functions. And it did not comply with the biodiversity information standards. The data were not provided to GBIF, of course. And the UCF, at some point, the UCF servers was going to be decommissioned. So there was the first database transfer. In 2011, the Ohio State University, thanks to Norman Johnson, was able to transfer our database to their database. And this was great because the OSU is a registered data provider for GBIF, and they share data in Darwin Core format. And so it was also a collaboration with IDIC Bio. And so UCFC could be integrated in the network of all other historic collections. But there were still a few limitations. The data were not entirely managed by UCFC and the collection manager. The data were not pushed to GBIF since 2019. And over the years, some functionality was lost.
And here where I come in, and we discussed a little bit in 2024 to really transfer the database to another kind of platform. And we decided to go with TaxonWorks. Those are the three people that actually have been able to start the project. At the beginning, Sean was not super happy because of the first transfer. He thought it was a little bit of work to do, and he was right. We decided to go with TaxonWorks mostly because it is open source, the entire database. It's a good platform. We can have data downloadable and uploadable in Darwin Core format. It allows the collection to have some sort of analysis down the line that we really wanted. We really want to dig into the collection. And then, of course, it's very easy to get out of TaxonWorks, and therefore we can get all those data from TaxonWorks eventually in the future and move it to another database. And of course, TaxonWorks also is supporting and it's collaborating with its own platform, which is a public interface, Taxon Pages, right? So we decided to go with that. And effectively, there are 3 steps, roughly, only 3 that we did. We exported the entire database out of OSU database. We did a little bit of tweaking, but substantially we created a Darwin Core formatting. So OSU already had a Darwin Core format, but it was not completed. And we had to manage a few entries specifically for TaxonWorks. So we did all of that. That took roughly 2 to 3 months, something a little bit more on that. We created also a guide for everyone being on the same page. And then we imported everything into TaxonWorks. And this is what it looked like when imported a few families. We divided the task by families, of course. And as you can see, we imported at the time more than 10,000 specimens. And this is just one of the many families that we represented, of course. Among all of this, we decided, like many other collections, to renovate the building. So here we go, me trying to move stuff around. Being very strong doing that. we moved to a temporary position, and right now we have this, that it's being renovated. The room has been renovated. We're trying to move back in maybe in spring. But substantially, all this was happening while we were transferring the database in a way. And at the end of it, right now, everything is transferred into TaxonWorks. We found one big problem. And this is where Sean was less happier than before. OSU did not allow us in a way, to download the entire specimens. This is due to the fact that some specimens were hidden into the database if you were looking for taxa. If you were looking for names that right now that are not available or valid anymore. And therefore, there was some issue. We substantially lost more than 42,000 specimens. And as you can see, I don't have the face of Sean, but you can imagine it. Mostly were lasioglossum, and therefore Sean was thinking, so it would take me 20 years to really understand what specimen we lost. But luckily, I developed a Python pipeline that were able to compare the two databases. So we download everything from OSU. Let's compare it to what we got. I felt very smart doing this, and effectively took us like less than a minute to do this. We were able to recover the 42,000 specimens. We imported everything into TaxonWorks again. And here we have our new public interface. We have more than 575,000 specimens. Now we can mine the collection in a way, and we were able to see what is our strength. And as you can see, finally, we have Hymenoptera as the majority of the specimen, not only Coleoptera. But not only that, we could see when the collection was built, the majority of it. And as you can see, it is between the 90s and 2012, which is when Stuart Fullerton was actually active there. So this is, for us, really cool. We know where we need to go right now. We need to sample. But we want to do a step further. And so we really want to understand how the UCF can inform local biodiversity. So this is the UCF, the round thing that you see. The red pin is where the collection is located. And all around it, the green parts that you see, that is the Arboretum, which is a wonderful natural land around the UCF. If we focus on here, you can see a very specific area right there in the red square. That's an area which is quite interesting, has a sandpine and rosemary scrub, and it is an endemic in Florida. The thing is, that area where you see the red pin as well, it's where we collected since 1990s. And right now the university want to develop it into a parking lot because in front of it we have the softball. So we decided, so how many specimens we have from there and how many species, maybe we can inform the upper administration. So we have roughly 27,000 specimens just from that point over there in roughly 1,600 taxa. So we're hoping that the university will listen to us and will not develop that areas. But of course, we want to do another thing. What about the usefulness of the UCF for regional biodiversity? So we decided to do one thing, and this is just rough numbers so far. So we take it Orange County, that is the thing that you see over there. We decided to look at how many Hymenoptera there are in GBIF, and there are roughly 144,000 specimen, a lot of it from iNaturalist. And so we take our own data, and we decided that that's the number that we have, more than 154,000. So we have more specimen from Orange County than actually GBIF. So I would conclude that UCFC is very useful for more regional biodiversity and could potentially fill the gaps between a major collection that maybe are not interested in Central Florida as a whole. So what the future hold for the UCF back closet? Well, we want to have a complete GBIF integration. We already are a provider right now, but we need to make sure that we have a normal pipeline so we can push the data into GBIF consistently over the years. We are now working with the wonderful species file group to make sure that that is happening. We want to try to gather more data in comparison between this global biodiversity identifier, which is GBIF, and our own data. So how is important for UCF to exist and therefore to fill those gaps in biodiversity? This is always to inform the upper administration potentially that we are useful. And then we want to publish a data paper so we have something substantial to show the administration. And with this one, we want to just thank the species file group and TaxonWorks overall to help us out, and especially Debbie that helped us at the beginning. The Department of Biology for some funding, the back closet, to allow us to represent it here. And I personally want to thank two people, Stuart Fullerton to start the collection that allowed me to work on it, and Song to improve the collection over the years. And that's about it on our end. Question. Yes, sir. So the question is, has the university decided what to do? I don't think so. Not right now. I think they are still undecided what to do, and we are hoping for the best results. So right now we're going to try to see what happens in the future meetings. Yes. Yes, sir. Yes. So the question is, we saw a difference between the GBIF and our own database. Shouldn't be there the same? Yes and no. So a lot of those data come from us very easily. The problem is that we didn't push anything since 2019. So all the things that you see are a blend of what we had before 2019 and what has been added after into GBIF. So what we want to do in the next step is eliminate from the GBIF data all our data and effectively see what we hold with respect to some other collection or some other iNaturalists, for instance, are able to push into GBIF, and try to make that sort of idea and push towards regional collection, small collection like we are. Yeah. Okay, thank you.
All right, and up next, Jessica Wadleigh with 140,000 tiny Rove beetles.
Great. Hello, everyone. I'm a collections assistant of insects at the Field Museum in Chicago, and I'm here to talk to you today a little bit about the curation of our collection of two very large Rove beetle subfamilies, the Pselaphines and the Scydmaeninaes. I want to give a little bit of a brief overview of our insect collections. You saw a little bit with Tatiana earlier, but we can go in a little bit more detail. At the Field Museum specifically, we are one of the top 5 largest here in North America, with approximately 17 million determined and sorted specimens. The number might be a little different. That's because it's an underestimation and we aren't entirely sure what our actual numbers are, and they're a bit outdated. So hopefully we'll figure that out more as time goes on. Of those, we have a pretty large pin collection with at least 6 million, vast majority of those being Coleoptera. You can see a little bit better on this picture how far that hallway goes. It's not just darkness. It's, I think, about 40 compactors, so 80 different rows. And we also have an extensive slide, alcohol, and cryogenic collection. Our bulk sample collection is one of the largest in the world, with 20,000 residues, most of which are partially sorted already for mostly like some groups like beetles and ants, but likely there still could be anywhere from 10 to 30,000 specimens per bulk sample. So that's a huge treasure trove waiting to be eventually sorted through. Focusing a bit on our staphylinids, or Rove beetles, due to a long history of employing many staff-focused curators and researchers, we have one of the best represented collections of staffs in the world. Our primary type numbers are only rivaled by the British Natural History Museum. These also include some acquired collections from a few familiar names, like Bernhauer, Burig, and Kistner, that are some major staff authors. But we do have at least 8,000 species of primary types of staphylinids, which I think is quite impressive. We've received a lot of donated collections, partially and fully, and type deposits over the years, specifically for our 2 focus subfamilies, which I've listed some notable contributors here. Some to point out a little bit, Henry Dybus and John Wagner were associated with the Field Museum, and Don Chandler is still depositing types to us to this day, which we're very grateful for. Now to the important groups that we're actually here for, starting with the Pselaphines. These little tiny Rove beetles are often myrmecophiles, so they're ant-loving. They often live with ants in a close relationship. Our Pselaphine collection is the largest and most utilized collection in the world with over 100,000 specimens. And I know this for sure. I've touched every single pin. So these include about 4,000 types, of which there are at least 425 that are primary types, and we've imaged most of those. Since the Pselaphines were added later in the 90s as a subfamily of Staphylinids, they didn't receive the earlier attention that some of the other staff-focused grants would have been curating towards, leaving them somewhat neglected, unfortunately. This was a priority to change, considering the value of this very unique and large collection and the risks of damage to the specimens, leaving them in their current state. And the Scydmaenids, Scydmaeninae, excuse me, are a collection of about 35,000 specimens. These guys face some similar issues. While not as large or as extensive as the Pselaphines, they are also neglected due to their even later addition to the Staphylinids, which is about 2009, I believe. They're also often little myrmecophiles. They live with ants as well, and they have a lot in common with the Pselaphines as far as natural history is concerned. In 2022, we received a return of loaned material, about 11,000 specimens, spanning a finally completed project that lasted over 30 years. And since we had to move the entire pin collection in the early 2010s, the space to reintegrate these return skids was not well accounted for at all. So we couldn't just put them back because there was nowhere to put them back to. That meant we had to try to get these recurated as quickly as possible so we could properly reintegrate them back into their current place in the collection within the pinned collection itself. This was an effort primarily headed by myself and a few very dedicated volunteers. Now, back a little bit to the Pselaphines in particular, we had in 2017 a NSF Pen Scan grant, and the story of curating them was a bit tumultuous, unfortunately. So after we received the grant, this was to primarily focus on unlocking the potential of our physical North American collections and make the data available through online digitization. Pselaphines were the primary focus group for this because they were the largest group that we were looking at. And there are 3 other families as well, the Teiids, the Tenebrionids, and the Zoophirids that were comparably smaller for our North American representation. From 2017 to 2020, we had several grant specialists and techs, along with a team of volunteers working on imaging all of the Pselaphine primary types, as well as digitizing the other 3 groups, which they just about completed in that time. The primary types for the Pselaphines turned out to be much more than we had originally expected. I think there was 140 estimated, and then we found out we had about 480 that we imaged. So there's quite a few that are, I think it's 425 is what I said before, that are primary types. And second, no, I can't scroll my notes. Okay, that's fine. But one thing that was unfortunate that happened during all this is in 2020, I was hired for the actual pre-curation and pre-digitization of the Pselaphine collection in order to prepare for digitization. Because if you just go in there, it's going to be very difficult to do. You can't just put the barcodes on if there's not enough space. And there's a lot of things that aren't in good shape and bad cork bottom trays and stuff like that. So the problem was I was hired in March of 2020. Which was not good for obvious reasons. So the pandemic hit, it was delayed. I didn't get to start going into the museum to work on this project at all until August. And even then, I was supposed to have a team of volunteers. I was supposed to have a bunch of people. I was alone working with one other person to help train me, and that was it. And I was doing all of this by myself, having to manually rehouse and move all of these specimens. So it was a very difficult situation. And as a result, you can see there the amount that we had databased at the end of it was about 6,800, which is not nearly the 60,000 that we were hoping for. You can see a little bit of the curation progress that we've had here. So illustrating this point, pre-curation in this example is to get the specimens ready for the digitization. So you rehouse them from cork bottoms in particular over to our nice foam bottoms, because the cork bottoms will rust the pins and then they're really hard to get out. And I had lots of calluses on my fingers. It was very laborious. We had to take inventory as well of the counts and all the taxonomy and their physical location, which you could see luckily. I have this, let's see if this video works. Oh, there's my mouse. So this is our Pselaphinae inventory. So it should scroll through, and this is only about 2/3 of it, but it keeps going for a while. So we'll let that keep scrolling. And so once we had the inventory, then we actually could update the taxonomy to what's correct and then go back and reorganize it so everything was in the correct taxonomic place. It's still going. Okay, we're good. Moving on. Maybe? Yeah, it just wants to do the video. That's fine. All right, of course, it's easier said than done. Naturally, there were many, many challenges we encountered along the way. Size constraints with these guys, especially. They're really, really tiny beetles. A lot of them are extra small. Some, I believe they don't get above much more than like 3 millimeters maximum, but there's a photo of one here, a little lamelba in this corner. The body to head size, like the full length of it, not including the antenna, is less than 1/2 millimeter. So they are very small. This unfortunately means they're also quite fragile, and they can take one wrong pin move and they fly off into space as a speck of dust, and good luck trying to repair or find that thing because it's unlikely to happen. Then there's also, manuscript names are a struggle. We have they're quite abundant in our collection thanks to Orlando Park's collection at the museum. He had a lot of incomplete works, and they still exist in a state of dubious uncertainty in a lot of cases, and either partially described or not at all described. So as a result, we kind of don't know how to digitize these sometimes, and it can be a bit of a challenge. Cataloging certain type names. We've encountered several types where the original published name in particular had the wrong gender suffix, which is interesting. And these were corrected almost immediately after. But that brings up the question of, do we database it as the original spelling? Or do we database it as the correct name, even because it was corrected? It's not an official published change. So if any of you guys know, have any ideas of how you do that, let me know, because we're still not sure. And even I was asking Alan Margaret, they don't know either. So also dubious taxonomy. I thought this photo was quite nice for it because it's got Pselaphinium problematicum is the name in there, which is how I feel about this group. So it can be really hard with these two groups, especially because a lot of the taxonomy for them isn't referenced online on GBIF or elsewhere, which can be hard to confirm or determine, even with our critical authority files that are very kindly provided by curators Emeriti, Al Newton and Margaret Thayer. Thank you, you guys. And I also, we're doing our best with it, but we manage to get as much as we can. And then, of course, incomplete data and label. It seems like handwritten labels has been a bit of a topic today because they are really challenging, especially if they're 100 years old. But we also get stuff where there's collection codes that we don't have any of the original notebooks for, or we don't know what it was associated with, especially if there's no other indication of who it came from or who collected it. It can be really hard to figure out what that data might even be. And then, of course, the workload. You guys saw how much was involved in having to move all of these individuals. That can be very labor intensive, and digitizing in itself is also very tedious afterwards, getting the data into EMU, which we use as well. And the collection events and sites, if those are brand new, that's even more work on top of that. And so now we're down to 2 collection staff and our manager at the Field Museum. So it's a little bit hard, even with our wonderful dedicated team of volunteers. Ongoing plans and some next steps. We're going to try primarily, as the most important priority, to publish a comprehensive type catalog of both groups with images as well. And this includes all worldwide types rather than just restricting them to North America, and imaging the skid types, which we haven't imaged at all yet. And there's a few remaining Selaphines as well that I would like to get imaged. Potentially, we could also go through and get some paratype representation if we don't have a holotype of that species, so we can have an even more diverse catalog published. And determining some type of status names as if they're syntypes or otherwise, so we can be certain from the original publications. For the skids, now that they've been rehoused and inventoried, we need to reorganize them. They need to actually be moved physically. Somebody has to go in there and move them back around to where they need to go. And so that is an important next step. Luckily, all of the 11,000 returns are there. They're just not exactly where they should be. So we got to be able to move some things around. And finally, we would like to continue with the digitization of the North American Selaphines. Even if the grant is now over and funding has run out, it would be even greater potentially if we could look into digitizing the Scydmaeninaes, because they are also mostly primarily in the Arctic and from North America too. So it'd be cool, and there's not as many, so we could work on getting those done as well. All right, I have a bunch of acknowledgements here. NSF, SCAN, which is not SCAN anymore, but ECN as well, and a couple people who are very important. And thank you very much. Any questions? Yeah. So the question was how many different angles we got for a photography system with the Selaphines specifically. The grant was written so that we would get dorsal, lateral, and ventral of all of the primary types. And we did also do some representative of the paratypes as well. So yeah, all three views, which is scary. I hate moving these guys sometimes, but it's definitely important. Oh yeah, those ones are. Yeah, they should be. Yeah.
I work at the collection at the MCC, and so I deal with a lot of Wheeler.
Yeah.
Types for misspelled. We've always gone through, if it's in the type catalog, we have the type number, take a picture and let the taxonomist sort it out.
So what was the question? It was the comment. Okay. We'll talk more later. Yeah. Thank you. Any other questions? Look like, yeah. Yes. The corrected name or original name. There's not a really good place in EMU to put it. We would basically have to create a new record of it as a synonym, which is a lot of extra work on top of it. So if we can avoid that, we would like to, but we will if that's what we need to do, if that is the general consensus of what's correct. Yeah. Good. All right. Thank you.
All right, folks, it is 4 o'clock, so please take your seats for the last stretch of today. We've got some great talks, so please take your seats. Okay, and I'm going to go ahead and introduce our next speaker as we take our seats. Our next speaker is Polina Mironova, and she has a question. Have you seen these?
Hello, I'm not an entomologist actually. I'm a mycology student from Purdue University. And I'm going to talk about fungal associates of insects. You can see the arrows pointing on the Beetles elytron, or the fungi that I'll talk about. So, how do I? Okay, thank you, Chris. So, what do you see on this image? Most of you would see a tiny point-mounted beetle specimen, one that's maybe a bit old and dusty. But what if I told you that there's actually more than one organism on this photo? So let's zoom in a bit. So these white threads circled in black, extending from the elytra and the tergites of this beetle, are neither dust nor Lepidoptera scales, nor are they the dreaded mold outbreak that most curators fear. In fact, we are looking at a fungus, but this beetle has been carrying this fungus during its life, long before its collection and curation. So let's zoom in a bit more. Oh yeah. An example of an actual mold outbreak. So under the microscope, circled in black again, you see hyaline fungal structures from a group called Labulbiniales. Each of these hyaline fungal structures is a single individual. So Labulbiniales, they don't form hyphae that spread across the surface. And then on the right image, you see the whole individual. So they all have a defined size and shape, and they stay fixed to one spot on the host with this black foot cell. So another word for Labulbiniales, it's a kind of a mouthful to pronounce, are beetle hangers, or labules, short. They're microscopic fungal biotrophs or ectoparasites. They attach themselves to the cuticle of arthropods, and most of them are quite species or genus specific to the hosts. And we currently know of 2,300 described species. But of course, with the vast diversity of insects. There's an estimated species diversity between 25,000 and 75,000 species. So there's quite a discrepancy in how many species have been described today. And then lastly, the transmission of spores happens through direct contact between the host, either through mating or grooming, or when they congregate together, like with these lady beetles. Well, these ones are mating, and the green things hanging off of them, the arrows are pointing them, are the lobules. So they're found across a lot of arthropod groups, mainly Myriapoda, Chelicerata, and Hexapoda, but this diversity isn't evenly distributed. So millipedes, we only know about 25 lobule species from them. From mites, we only know 70 species. From harvestmen, my favorite example, only one known species because nobody has looked at them before, basically, and they've discovered one species in 2017 from a museum collection, actually. And then all of the rest belong to Hexapoda, over 2,000 species. And then looking at the primary host groups, Coleoptera and Diptera are the primary host groups. 80% of Lobulbianale species associate with beetles, and 10% with flies. And then primary host families within the beetles are Carabidae and Staphylidae. So their diversity really succeeded and radiated on Coleoptera. But there are also some minor host groups that have a lot of interesting species as well. A lot of Heteroptera carry them, as well as Blatodia, so that's cockroaches and termites, ants, Orthoptera, some thrips and some bird lice also have them. So despite their known diversity, our understanding of them is still quite limited. There are many rare species. I just looked it up. About 70% of the species haven't been seen since their description, which is a lot. They come in very low prevalences, typically 1% or 0.1% in natural host populations or in collections. And there is some geographic biases. So the US is quite well studied for Lobulbianales. We have about just under 400 known species here, all contributed by one guy who was working on this group 100 years ago. But even looking at a smaller spatial scale in the US, you see some gappy distribution. So a lot of the west and the middle of the US, we don't actually know which kind of species are here. And from iNaturalist, 90% of this observation is just from one species. And there's a similar pattern on GBIF and Mycoportal, which is a database for fungi. And then, of course, I'm sure with insect, this is the same problem. Southern Hemisphere and in a lot of mega diverse countries, they're just totally underreported. We don't know much about them there. So we can bridge those gaps by using collections as a resource. These fungi are able to persist on dry pinned or ethanol preserved specimens, even decades after collections. So there's lots of opportunities still to describe new species, new host records, and get new geographical records, which helps kind of fill in distributional gaps and disjunct distribution, and also help us understand more about the co-evolution between the insects and the fungi. And this is where I think where entomologists and mycologists should join forces. Entomologists typically handle hundreds of specimens during sorting, mounting, or when they're taking images, or when they're looking at characteristics for identification. So there are also far more of you working on insects than there are mycologists that are working on this group specifically. So awareness amongst you is amongst you and collection volunteers and students, of course, is key to finding new cases and new species, especially with how low the prevalences are. Every observation counts. So I'll give you some tips and tricks to recognize if you're interested in finding them in your own collections. So what you need is just a stereoscope with some good lights or a macro lens. Their size range is between 35 micrometers to 4 millimeters, but they're typically around 100 microns and 200 microns. So they come in all interesting shapes and sizes. You have fancy ones like the F on the upper left, your upper right, yes, and more simple ones. And they come in all colors as well. On the host, they appear as tiny, pale to dark projections, and they don't brush off easily. And they can occur in small clusters all over the host, like on the elytra, the antenna, the legs, sternites, tergites, anywhere basically. Or they come alone. And one important characteristic to be able to distinguish them from debris, like Lepidoptera scales or dust, is the dark foot which attaches to the hosts, so which are the arrows that are pointing towards them. And now I'll give you some actual photos of the hosts with the lobules. On the left, we have a harlequin lady beetle, and you can see a cluster of the lobules on the back of the elytra. This is an easy one to spot. It's also one of the most common species that I showed you on the iNaturalist map. On the right, you have another contrasting host color and lobule color. We have some strange dark bristles on the elytra of the beetle, which are not hairs from the beetle itself, but are actually the fungus. Now I'll show you some more challenging ones. If you are able to spot them, on this one, you're able to spot any kind of lobules. So let's zoom in. This is a diticid beetle, and we're looking at the elytral margin of the beetle, and you can see some tiny, tiny projections where the arrows are pointing to. And if you can't really see the thallus itself or the individual, you can see the dark foot. Another challenging one, I'm trying to train your eye. We're looking at the last sternite of the diticid beetle. We see two fungal individuals that are kind of curved, and the arrows are pointing towards the dark foot. So this is another challenging one because of how small they are, not because of the color, and because dung beetles are often quite hairy. So this one is hidden in the groove where its head is bending towards its body. And they don't only grow like on the body of the host, but they can actually grow on bristles as well on the host. And then to end off on an easy one, this is a specimen in ethanol, a Pederis, another staphylinid. This one is quite obviously infected everywhere on its head, on its antenna, and its eyes. So anyone who works with specimens and manipulates them and looks under the stereoscope can help. In the QR code, there's a help sheet, or it's basically a summary of this presentation with my contact info. So if you've ever seen them before, or if you find them in the future, please contact me. I would be very interested in identifying it for you, or in the case if it comes from a obscure place, like a country in Africa, there's potential to describing new species with you. So, and with that, I'll take questions. Yes. Yeah. Okay, so the question is if they impact the insects. We actually don't really know what they do on the host. So some of them penetrate the host cuticle, others don't. There are some studies that say that they lower the fitness of the host, but they're really not replicated at all. So the impact on the host is minimal. And in collections, they're actually dead, so they don't impact collections at all. Yes? The question is if they're ever orange. Yeah, they can be orange. So the question is if they're ever on Lepidoptera. I don't know any cases of them being on Lepidoptera. No, but it doesn't mean that they're not there. I think they're just that group we don't really look at. There's kind of screening bias because we know that they're very prevalent on beetles and carabids. We're mainly focusing on carabids. So if you work on other host groups, that's also very interesting. Yeah. At the back. Okay, the question is if there are any on insects that are arboreal and not on the ground. Yeah, I know of examples of chrysomelids that are infected by those fungi. Yes. Methods of preservation that damage them. I don't think so. No, I think freezing, cryo, ethanol preservation, they all stay. I know with dry specimens, they can become a little bit brittle, so they can break off a little bit easier than, but it really depends on the group and how old the specimen is. Okay. Thank you.
Presenters are Connor Sue and Cole Cramer with Cultivating Curiosity.
Hey everybody, I'm Connor Sue.
And I'm Cole Cramer.
And we're juniors in high school at La Cañada High. And this is actually our first presentation at a conference for entomology, and we're really excited to be here.
And today we're going to be presenting about cultivating curiosity and inspiring the next generation in entomology. So basically, Connor and I aim to educate, inspire curiosity in youth, usually around ages 4 to 13, through engaging and hands-on experiences and activities. Our goal is to expand youth involvement in entomology by promoting education and environmental awareness, as well as community engagement by connecting youth learners through nature, through shared experiences. So back in 2022, Connor and I met at the UC Davis Bio Boot Camp in Sacramento. For those who don't know, that's around 8 or 9 hours away from LA, where we live. Now, while we were at the camp, we both discovered we had a very strong interest in entomology, and we also found out we lived only 20 minutes from each other. It's crazy to think we met so far away.
So after we discovered that we lived so close, we started hanging out almost every day, building traps, playing ping pong, doing whatever. And we loved having each other's company because it was hard to find a friend with such a niche interest. So it was a really big step towards creating our program. And we also have been setting traps we went to the mountain community of Wrightwood, and we set some panel traps and lingering funnel traps baited with ethanol ultra high release and alpha pinene ultra high release. We got many cerambycids and a wide variety of insects. So why we founded the Lorquin Scholars. So as you know, Cole and I already stated that we met in middle school, and we were both already part of the Lorquin Entomological Society. And it was mostly comprised of older senior entomologists talking about bioinformatics, things that were a little bit too advanced for us at the time. And we also noticed that there was a lack of resources for kids. They were either too advanced or too basic. And as we grew older, we wanted to fill this gap. And that's essentially how we made the Lorcan Scholars.
So now we're going to show you guys some of the bug hunts and youth events that we participated in over the past few years, such as hikes that we've been on, that we've hosted, and even booths and events that we've been invited to by LA County Parks, as well as the Natural History Museum. So our first hike that we did is the JPL youth hike in Pasadena, which is Los Angeles area. Now this youth hike, we took around 15 kids to explore the riparian zone and look for our various arthropods using beating sheets, aquatic nets, and aerial nets. It's actually really cool because the kids have never seen aquatic nets. They had no clue nets could go in the water. And we've got dentistids, hydrophilids, and even some toad gliders. It was very cool to show the kids the biodiversity of an aquatic habitat. They were also very interested in exploring the aquatic ecosystem, as I said, as well as exploring the differences between chaparral, riparian, and aquatic habitats. Here's some pictures from the event. Here's a quick flyer that we put together, accessible, has the date, location, date, location, time. Third or second picture, I'm showing the kids tusker moths and how they're pupating on different Quercus species. And in the third picture, we have a very enthusiastic little boy that is showing me insects that he recently caught.
So the following month, we hosted a youth hike in La Crescenta, Los Angeles. And we were mostly trying to teach the kids about how to use tools such as sweep nets, beating sheets, and even pooters or aspirators. And we were super impressed by this one little 4-year-old girl because she absorbed all of the knowledge that we were talking about to the group and teaching. And it was just, we were blown away by how much she absorbed. And there was also one really observant kid who spotted an Ammophila carrying a paralyzed caterpillar back to its nest. And we realized that this was a perfect transition into talking about the different relationships between insects and their hosts or prey, from mutualism to parasitism. So in the bottom left, this is Polina showing diabolical ironclad beetles and the structure of their exoskeleton and how they're so durable. And on the right, this is Polina teaching all of the kids how to use pooters for smaller insects.
So now we're going to show you some community outreach booths for events that we've been invited to.
So we had a Burbank Earth Day event, and it was started out rainy and there weren't a lot of participants, but as the sun came out, it became a really, really awesome experience because there were so many people coming, and we're mostly focusing on decomposers and their impact on our environment. And we had some roaches and millipedes showing that not all roaches are the pests that many people think they are. They're actually really important to our environment. And we also had scarab beetles and dung beetles to show that they're actually really important in decomposing fecal matter. We even had a paper mache dung ball that we made to show ovipositing and how they lay eggs. And then we had 12 of our curated drawers that highlighted morphology, life stages, and we even had a local species drawer to show different adaptations in California. So here you can see we're very engaged with the kids, showing them how to carefully handle different insects, and this is us on stage presenting.
So next we have our San Gabriel River Park grand opening. This was the opening of a new natural area that will hopefully be preserved from industrialization and other external factors. But we were actually invited out by LA County Parks to participate in this event, and hundreds and hundreds of families showed up. Even the adults were super interested in learning about the insects that we had to offer. We had some scorpions to show the kids difference under ultraviolet light. This is actually one of our first LA County Park events that we participated in. And from then on, we went to do 7 or so more. Here's some more pictures from the event. As you can see, the kids are super interested in looking at our boards and what we've curated over the past few years.
So we've had a booth at the Natural History Museum of Los Angeles annual bug fair for around 3 years in a row. And it's an awesome opportunity because this year there were over 8,000 attendees, and we got to reach such a wide audience and got tons of signups for our program. And we had some interactive touch tanks with multiple different species of mantises, more cockroaches, and more millipedes. And the kids were super interested in these mantises because they've seen them in their backyards before, but didn't know anything about them or didn't know if they were dangerous. So watching them handle them with such enthusiasm really warmed our hearts. And with the drawers that we had this time, we were talking mostly about the importance of curation to the scientific community and how we collect and curate our specimens. So here you can see there are tons of people at our booth, and everyone's really excited and engaged, and we had a great time.
And we also taught the kids the importance of holotypes and paratypes and how they're really influential and important to the scientific community. So next, this is our biggest event so far. This was the Mercury Vapor and Black Lighting Night at one of our local nature centers. So it started around 7:30 and we got there early. It was no moon, warm Saturday night, perfect for setting up lights. It was a great turnout, over 60 kids. It was perfect. We brought our 400-watt mercury vapor with our ballast, carbon fiber tripod, and even around 4 or 5 black lights.
So we also provided the kids with UV safety glasses and the adults to make sure that they had no damage to the eyes when around the black lights or mercury vapor lights. And for beginners, we also provided more colorful nets for collecting to increase engagement and just have resources for kids who might not have had their own nets. There are over 60 kids and parents, which is awesome for a black lighting event. That this was our first one. And we had 6 specimen drawers teaching around the same things that we taught in our other booths. And we ended the night around 10 p.m. because they're little kids. They still had to go to bed early. And we taught them at the end of the night how they can set their own blacklight traps in their own backyards using simple hamper setups that they can buy off Amazon.
Yeah, and also record insects they found on INAT and contribute to citizen science through.
So here you can see everyone's looking at the sheet, super excited. We're collecting some insects to show them in vials. There were tons of serendipitids again, some owl flies and acorn weevils. It was awesome.
Yeah, it was really cool to show the kids what can come in like at night, because they're not looking for bugs at night. They're looking on leaves in the daytime and other stuff like that. But we also showed them how to take insects off the sheet without damaging them or like crushing them into oblivion.
So outreach and promotion. So we make one-page flyers similar to this one that you can see. We share our mission, our goals, and different events that we do, things like that. We hand these flyers out to nature centers, libraries. We hand them out at community events and even to elementary schools. And all of these organizations are really supportive of us because we're really the only outreach program for kids in Southern California. And we also run an Instagram account to show our whereabouts, different things like that. And we occasionally post fun facts about insects. And lastly, we have an RSVP form and an email list to give what we're doing later on.
So moving forward, Connor and I plan to expand our programs and reach even more youth, maybe throughout the country at some point. We plan to build even more partnerships with organizations such as nature centers, museums, maybe even universities that allow the youth to better understand our environment. Together, we will inspire the next generation in the wonderful world of entomology.
So over the summer, we're really hoping to have an internship or any opportunity to gain more experience. And if anyone here is interested in or open to talking to us about this later, then we would love to talk to you later. We would like to give special thank yous to Dr. Oliver Keller for being our advisor and helping us and being so supportive along the way throughout our whole journey, and to Dr. John Harity for really introducing what ECN really was to us.
We'd also like to thank Lorquin Society for inspiring us to make a kid program, as well as Natural History Museum of LA and LA County Parks for inviting us to have booths and us to participate in events in general. Also, a huge thanks to Miss Tabitha Yang at UC Davis, because without her, we would have never met and would not be presenting today.
Thank you so much.
Thank you. Do you have any questions? Yes.
Yeah, well, many of us in this room who started at your age with entomology. I also was very lucky at 14 years old to meet a friend in secondary school who had the same interests. And
Yeah.
we did a lot of things together. So I really commend what that you're transmitting. And I'd like to plant a little seed maybe for next year. Is that we have a small symposium where we have like short testimonials, 5 minutes from those of you who want to start to talk about how you started became interested in entomology at young age. We haven't covered that yet in ECN. That would be great. So,
That sounds great. Thank you for your
Thank you.
support.
thank you.
Thank you.
Great.
Thank you.
The work you're doing with this outreach and turning back and bringing more older kids can help them organize in expanding further, or in terms of how the insect collection work that you're doing, where you have these beautiful boxes that inspire other kids your age to start collecting and boxes.
Yeah, so the question was if we're inspiring or having other older kids to help us teach the different hikes that we're at. So we do have a few other different friends who are also interested in entomology, not as much as us, but they're still helping us lead the hikes and teaching the basics of entomology. And we're trying to expand to different areas of Los Angeles.
What opportunities do you think you would like to see from entomological in the young or collection and the big band? Like you can have a good scenario.
Yeah.
What taxon?
Yeah.
So the question was, what taxon are we interested in studying, and what would be an ideal opportunity for us? So I'm really interested in cerambycids and buprestids, cicindelids, and Cole.
Yeah. I'm interested in Trichinae, so I'm a cave guy. So if you have any. Yeah. Yes. Yeah. The question was, how do we pretty much make our boards the way they are, how they're, I mean, we're kind of perfectionists. So we make detailed labels, special paper, museum paper. We also order our pins from Ecology Supplies, the best company there is. But we always get the most high quality material there is to offer, and a lot of time and dedication and practicing to perfect our skills.
We try to meet up around once a week to pin all of our different specimens that we've gotten from collecting trips and different things like that.
Yes.
That
would be awesome.
That would be awesome.
Are wanting to do their own outreach program. I am the outreach coordinator, and I'm going to hand you some business cards.
Thank you so
Thank
much.
you.
I've been interacting with collections of fair bit now. What can collections do to help you on your mission? What's missing from collections?
Yeah.
Resources they provide.
So the question was, what can the collections network provide us to better our program, essentially, or collections in general? I would definitely say equipment is the main thing. We need equipment, we need hitting supplies to really teach the kids the best practices, pretty much, on what they can do to kind of upscale their knowledge.
Thank you.
Right, that was great. Up next, we have the first of our pre-recorded lightning talks. Christina Watkins talking about telling human stories through collections.
And it is useful as different biota inhabit these regions.
Oops. Not that one.
My name is Christina Watkins, and at the University of Florida, I'm a PhD candidate in entomology, which means that I've always here, I spend a lot of time in insect collections. And the more time that I spend in them, the more I find myself really conscious of the fact that I am connecting with, understanding, and receiving them in a way that I can only describe as really innately human, which makes sense. I can't turn my fingertips at the door, but I can, and our fingerprints are physically and metaphorically all over these spaces and specimens, as ultimately all the work that we do with them is a innately human experience. And this humanity is something that I think collections have really begun to recognize as a valuable tool during outreach, as it allows us to utilize this sort of human self-centeredness in a way that forges connection with the average person. However, may I say, I think that a lot of us are completely overworked and we don't have the time or the bandwidth to think about how to tap into people's humanity during outreach in a way that is methodical, feels interesting, or has specific routes involved, to make our statistics and ultimate meaning behind our work feel more impactful to the average person. So I have done the work for us, and I've created a resource that I believe to be pretty comprehensive of all the ways that we can tap into people's humanity during our entomological outreach. This is a document that I hope that you all will share, especially to people who are potentially new to outreach. It's really high quality. If you utilize this QR code, it might take a moment to load. And if QR codes aren't your thing, by the way, feel free to send me an email and I will get you a downloaded version of this document for you to share, print, and read. There's a lot of information on it, so being able to zoom in on it, I think is really helpful. And this document outlines the sort of big picture ways that we can tap into humanity during outreach. These are story, identity, and emotion. And there's subcategories in all of these, which I think is really helpful for not only reminding us with outreach experience as to what's important to tap into, but also is important to establish within people who don't have that much outreach experience and maybe looking for really specific examples that they can utilize. And I do provide many of those specific examples. For each one of those big picture and big picture subcategories, I provide examples that are both inexpensive or can be made into something very involved, whether that be time-wise or financially. I have both interactive and hands-off examples with a variety of in-between stages that should be ultimately accessible for any collection, no matter how many resources you have, what specimens you have, or what the quality of those outreach stores may be looking like. This is an adaptable resource that you can use for specific examples as well as for inspiration as you go and try to tap into humanity with your outreach. And so, that I don't have time to go over the entire document, here it is, and I hope that you download it, share it, enjoy it, and get a lot of use out of it. And thank you all so much for listening.
Yeah. We won't on the other ones, but if you want to see, I'll try to get, you can get the QR code there for a moment. Yeah, I know, we won't have it on the other videos. So up next, we have Taylor Kane from the University of Alaska Museum. One Small Step for Bug Kind, outcomes from a week-long entomology camp for teens.
Great. So yeah, I am Taylor Kane. I'm a PhD candidate at the University of Alaska Fairbanks and the University of Alaska Museum. And today I'm going to be talking about an ongoing effort to get local kids more interested and involved in entomology. So I did this as a part of my graduate certificate in scientific teaching and outreach, which is a program offered through the University of Alaska Fairbanks. I took various classes, and then the certificate culminates in an internship. I chose to do an out-of-school education internship, and so I developed and implemented this camp. I was really interested in doing a entomology camp for teens because we already have multiple entomology camps for younger kids and adults offered through the university, but there's really nothing for high school age kids. And I developed this course with the help of Dr. Laura Connor, who was my mentor during this internship. So entomology camp was a week-long 5-day camp for 3 hours every day. Kids came to campus. It was students in grades 7 through 12 were eligible to participate, and we capped it at 16 participants. And it was taught through UAF summer sessions, which is important because it meant that they handled all of the logistics and the registration and the emails and the buying supplies, and I didn't have to do that. I just had to show up and teach kids about bugs. And this camp was highly inspired by the bug camp that my advisor, Dr. Derek Sykes, teaches. I've taught bug camp with him several times, I don't know how many times, and also by myself several times as well. And he and his wife Mel's approach to camp outreach and really just getting kids interested in hands-on collecting has really inspired my outreach work in general. So for the learning goals for entomology camp, the first was that I wanted students to be able to identify insects to the order level after camp. The second is that I wanted them to have a better understanding of ecological roles that insects play. And I wanted them to have an increased awareness of insect diversity. And finally, I wanted them to create their own collection, which they would be able to take home with them at the end of camp. So this was achieved by spending a lot of time outside. We would go outside every day, collect, observe insects in their natural habitat, do some nature journaling, all sorts of different activities. Then they would bring their specimens back inside where they learned how to pin them, how to make data labels, how to make ID labels, looked at them under microscopes, and just spent more time with them, and then ultimately creating that collection. So the lesson plans varied each day. Each day had a different theme and objective. So an example could be Botanical Garden Day, where they were learning mostly about ecological roles. I also had bugs of the day depending on what the theme and the objective were. And so they would learn about that insect, how to identify them, diagnostic characters, and we'd discuss interactions they'd had with those insects in the past. And then we had different activities every day. I tried to do nature journaling every day. So for example, for Botanical Garden Day, the nature journal prompt was to observe 3 different ways they saw insects interacting with plants. Then we went and collected in the botanical gardens for about an hour. When we got back, we had a group discussion about what interactions we observed and what the ecological roles of those might be. And then on that day, they also learned how to use microscopes and continued working on their collections. So there's a lot of different ways to measure what the kids were getting out of these camps. One of the really obvious ones is the collection they're physically producing. And you can see there's a lot of variety in what they created. Some kids just wanted to collect everything they could. Some kids are interested in specific groups, and some kids tried to form more synoptic collections. And I also spent a lot of time doing art with them, which is also a really good way to measure how engaged they are and what they're learning from the experience. That said, I wanted to do a more in-depth study to see what the actual impact of this camp was. So I conducted a pre and post survey on the first day of camp and on the last day of camp, looking at how insects felt about insects, how students felt about insects, how students acted towards insects, and what students knew about insects. So in total, even though I had 16 kids in camp, I ultimately had a sample size of 12 because either the children opted out of participating in either the pre or the post, or their parents opted out of them participating. So keep in mind as I go, a fairly small sample size. For the first assessment of how students felt about bugs, I looked at 3 questions: how they felt about specific insects, how they felt about insects in general, which was an open response, and then also how their families felt about insects. So I gave them this. This is a Likert scale. It's pretty standard. They could say they hate them, they dislike them, they're neutral, they like them, or they love them. And then on every question, they had an option to not answer. And I included insects I thought they'd be familiar with, and used common names for all of them so that they'd have a higher likelihood of being able to kind of have some emotional association with the groups. There's a lot going on here. I'm going to orient you guys before we talk about the actual values. So we have our Likert scale on the y-axis here. The lower the value, the less they liked it, the higher, the more. We have different orders of insects here. So we have bees, beetles, butterflies, dragonflies, flies, grasshoppers, spiders, and true bugs. And then within each of those columns on the left, we're going to have the blue, which is the pre-survey mean, and the green, which is the post-survey mean. So the main takeaway here is that the only differences that were statistically significant were increases, which is great. No one liked insects less after participating in camp. And so you see, in general, we have these big changes in flies, spiders, and true bugs, and then some small, non-statistically significant negative changes in grasshoppers, dragonflies, and butterflies. We'll get to grasshoppers later, but butterflies and dragonflies scored so high in the post that or in the pre that there's really nowhere for them to go but down. And then I did the same thing for specific groups. So in the top here, if they're in green, I expected them to like them. If they're red, I expected them to maybe dislike them or be scared of them. And if it's black, I expected them to kind of have neutral feelings towards them. And the only statistically significant difference here was for wasps, which we saw almost an entire point increase in how much students reported liking wasps. And you could admire here, mosquitoes are very disliked in Alaska, and even despite my hardest efforts, I couldn't get kids to really like mosquitoes. And then all of the other groups, except for honeybees here, honeybees went down slightly. Sorry if anyone works on honeybees. But all the other groups, we saw slightly positive, non-significant increases. And then when we sum all of those together and look at the overall change, we see an average overall pre of 3.7 going up to almost 4. So that would be that they like them on average. And that difference was statistically significant, which is great. I also asked them open-ended how they felt about insects. And so you can see there's some changes here. Again, I categorized their responses into different categories. So we have if they liked or loved insects, thought they were important, thought they were interesting. Those are all in green because they're positive emotions. And then if they disliked or were scared of insects is going to be in red. Again, pre is going to be in the lighter color on the left. Post is the darker color on the right. So you can see there's a large increase in the number of students who said they liked insects, a decrease in the number of students who said they disliked insects, and a decrease in the number of students who thought they were scary. In order to kind of evaluate this difference, I made them into percentages. So if it was 100%, that means they only said positive things. 0 was they only said negative things. 50% would be 1 positive and 1 negative, and so on. And so we see actually a pretty huge increase from 68% to 92% in the post, but unfortunately that difference was not statistically significant. Then the other thing that I evaluated was how their family felt about insects. There was no change in the pre and post, so we just have overall family response here. And so you can see it's generally positive. But the thing that I was interested in looking at with this was if there was a correlation between how the family felt and how the student felt in the pre, the post, or the change that we saw in students. And there's no correlation at all, which I was really surprised about. That student feeling seems to be somewhat independent of family feeling, although I think I had a biased sample of kids who opted into participating in a bug class. So when we look at our assessment, we saw a statistically significant change in specific feelings, a non-statistically significant increase in general feelings, and no change in family feelings. For the second assessment, I looked at how they acted towards bugs. So I asked them how often they observed bugs, how often they interacted with bugs, and then I asked them what they would do if they found a bug in their house. There was no difference in how often they reported seeing insects, which surprised me because there's 5 would be every day, and there's definitely not bugs visible in Alaska every day of the year. In fact, the majority of the year, there's no bugs visible. This was in midsummer though. But we did see a difference in how often they reported interacting with insects, which is great because they were spending the entire week interacting with insects. And that difference was statistically significant. Finally, I asked them what they would do if they found an insect in their house. Again, we have pre and post, and then red is negative emotions or negative actions, green is positive ones. And there really wasn't much of a difference. We saw actually 1 increase in the number of people who said they would kill things. And someone said afterwards they would add it to their collection, which was a lovely response. And there's some nuance that's being lost here. For example, we had this response of, I usually kill them, sorry bugs, which before they just said I would kill it. So at least now they're apologetic about killing it. So in total, looking at observation, there was no change. Looking at interaction, there's a statistically significant positive change. And looking at actions, there was really no change. For the final assessment, I was looking at what they knew about insects. So I was asking them to identify an insect, draw legs on an insect, and list ecological roles of an insect. So I gave them a beetle, a fly, a spider, a nabbit, and a millipede, and asked them to say yes, no, or I don't know. The pre-accuracy and post-accuracy were the same for the beetle. Everyone was able to say a beetle was an insect, but for the other groups, it was lower on the pre. So we see an increase from 88 to 100 for the fly, 63 to 83 for the spider, 90 to 100 for the nabbit, and 70 to 73, not great, for the millipedes. To be fair, they probably are not super familiar with millipedes because they're not in central Alaska. So we do see about a 10% increase in accuracy between the pre and post, but again, not statistically significant. So then to test their understanding of insect anatomy, I gave them a legless insect and asked them to put legs on it. I was looking for two things, the placement of the legs and the number of legs. So even though these two responses are vastly different, they both were considered correct because there's 6 legs and they're all on the thorax. In contrast, these ones were considered incorrect because while there's 6 legs, only 3 were on the thorax. So there's actually no difference in the number of legs. Kids knew even before camp that insects have 6 legs, which is great. Public education. But the placement of legs did vary. So it was 72% accuracy on the pre versus 83 on the post. So again, a big non-statistically significant increase. And then the last question I asked them is if they thought insects were important, why or why not? I would change how I worded this question if I asked it again, because a lot of the kids interpreted it differently than I meant it. A lot of kids just said they're important because I like them, which was not really what I was getting at, although it was nice. And so I ended up evaluating this question based on the number of responses they gave. So in the pre, on average, they gave 1 response for why insects were important or 1 reason. And in the post, it went up to 1.33. But again, that difference was not statistically significant. So overall, then we see that identification, anatomy, and ecosystem roles all had somewhat positive but non-statistically significant increases. So overall, no one knew less about insects or liked insects less, which I will consider a win. But I think there's also a lot of things that kids got out of this camp that can't really be reflected in just the numbers. And on the post survey, I actually asked them specifically what they liked and didn't like about camp. So a lot of the likes were collecting specific things, making their collections, pinning things, being outside, and a lot of kids just said they liked everything. There's nothing they didn't like about camp. A lot of the negatives were actually positives. So multiple people complained about not having enough time or wishing camp was longer, which is great. Grasshoppers, we had 2 complaints about the numbers of grasshoppers, which I think you can see in that the average rating of grasshoppers went down. This is very relatable. And then a lot of kids also said that there was nothing they didn't like about camp. And this is reflected too in, I offered this camp in 2024 for the first time, and I offered it again this summer, and I had many kids come back to take it a second year, which is great. Again, I want to thank all my STO instructors who really have helped me develop my outreach approach and just my approach to teaching science in general. Derek and his wife Mel, who have also shaped my work a lot, and the summer session staff, who honestly, I don't think I would want to teach a class. If I had to do all of what they do myself, it would not be fun. And also ECN for funding me to come talk here. Yeah, I'm happy to take any questions.
Curious on what the famous view of the students were, and if there was any vendor for this.
I didn't look into that. Thinking off the top of my head, I don't. Oh, the question, sorry. The question is if there was a skew in how many girls versus boys were enrolled in the class, and if I saw any impact of that on the response. And it was about 50-50. I also had multiple non-binary students participate both years. And I didn't do the actual analyses, but thinking off the top of my head, there was girls who were super into it, boys who were super into it, both groups that were like, my parents made me come here and this is not my idea of a fun time, but ultimately did enjoy camp. Yeah, so I don't think there's any influence of gender. Yeah. Yeah. Yeah, oh, here, can I scroll? Yeah. Yeah, that's a good point. So the lowering in both butterflies and dragonflies, if you look, there's just like this one outlier here and then this one here that I think the average, if I'd remove the outlier scores, probably would have been about the same between the pre and post. No idea. That kid rated everything highly and then was like, not butterflies though. Everything else was high. Yeah, very possible. Yeah.
We get some kids who say, I don't want to kill insects, it's not good to kill them, and what would you argue for the making that other kid could kill them for collections?
Yeah, I haven't had that issue with the older kids, but I frequently have the question, sorry. The question is, are there sometimes kids who don't want to kill insects and how do I deal with that? And I haven't had that issue in either of my camp for older kids, but I do frequently have it with the younger kids. And I always tell them that the point of camp is that we're learning about insects and they can choose to do that how they want. If they don't want to kill insects, they can't. We have like what are they called? The critter keepers, and I'll give them like snap caps so they can collect things, but then let them go after the day is over. But I tell them that how other kids choose to learn is not up to them, that they can choose for themselves to not kill things, but they don't get to choose that for other kids. And then I just talk about the importance of collections and why we kill things, and it's not just to be mean.
I remember fellow entomologists in China said that the Thai entomologists, once a year, they go to a Buddhist prayer day to ask for forgiveness for the insects they kill as part of their work.
Yeah, I try to emphasize a lot to kids because there's definitely some kids who are into killing insects and that aspect of it. And so I try to emphasize a lot with all the outreach I do that it's respectful and we're doing it to learn from the insects and we're not doing it to be mean, and we never want them to suffer. So we always want to end their suffering as quickly as possible and the ultimately benefit. So they gave their lives so we could learn. And so we're going to use them to learn.
But I wanted to know a little bit more about how you develop these survey tools and if you have plans to validate them in the future.
Yeah, so the question was about how I develop these tools and if I'm going to continue to do the surveys in the future. I'd really love to. I'd love to increase the sample size. What I really want to do is a longitudinal study. So look at not just have they changed after camp, but is that change sustained? Like if we look 6 months later or 1 year later, do we still see these improvements in how they feel about insects? Logistically, it's really difficult to get everyone back. Like I could do this because I physically had them in the classroom and I could say, sit down, we're doing the survey. And I think it's really difficult to do that. It's really also difficult to get IRB approval for human studies. That's not my favorite part of this. And so it's definitely like, if I do it again, I have to go through that entire process again, which takes months and months, but is something I would potentially be interested in. Yeah. Okay.
Okay, and up next for another of our virtual talks, Marian Kirst with Stupid Serendipity, State Record Beetle. Emphasize
say it in the
Oh
video.
dear, let's go with that.
Hey everyone, welcome to my ECN lightning talk entitled Stupid Serendipity, presented by me, Marian Kirst. So at the end of last year, we published the first report of the Great Plains tiger beetle in the state of Montana, where I'm from. And this find was notable for a couple of reasons. It was the westernmost and northernmost record for the species, and it was also the first new state record for Amblychylus lentiformis in 50 years. But this find required a fortuitous intersection of events. So many things had to come together at just the right time for this funny little state record story to play out the way it did. It all began 30 years ago when the paper's lead author, Dr. Mike Ivey, first began searching for Amblychyla in southeastern Montana, right about here near Broadus. But despite a wealth of suitable habitat, he didn't find anything. Fast forward to 2009, a father-daughter team are bug hunting in south central Montana for the daughter's private school-required insect collection. So by this time in Montana, physical insect collections had all but disappeared from the public high school science curricula, which administrators justified using dubious arguments about ethical concerns, cost, teacher and interest, etc. Anyway, Art and his daughter loved this assignment so much, they continued collecting the following summer. And it was during this time that they find a bunch of big brown beetles on their neighbor's land. The father, Art, assumed that these critters were just some common ground beetle because they were quite large and everywhere. So Art and his daughter added a few of the beetles to their growing collection alongside some butterflies and moths. Skip ahead 14 years to June 2024. Yours truly is now a working sort of entomologist doing bees and moths and lots of outreach, including a moth and bat night program with Montana Fish, Wildlife and Parks. And this is where I first meet Art. He brought along part of his and his daughter's insect collection with the hope that I could help ID some of the leps, many of which I noticed were coated in glitter, an anti-cheating protocol apparently. But also in the collection were 2 Amblychyla, which I only recognized as unusual and only recognized at all because, like other filthy generalists, as we're often called, I'm interested in all the things and like to leisure read field guides and star mark insects that I want to see, including at the time Amblychyla. But at this point I knew they were known only as far north and west as Wyoming and South Dakota. I was surprised then to learn that Art had collected these beetles just south of us in Bighorn County, Montana. So I took a picture of his specimens and texted my colleague, Dr. Ivey, to ask if there were any Amblychyla records from my area. He didn't text back, but immediately called. Don't bleeping tell me you found them. So I explained the situation and was told essentially to figure it out. How and when to get us to the collection site, which turned out to be on a swath of private land that Friends of Arts were leasing from the Crow tribe. After some back and forth, we finally obtained permissions and assembled a field team. We arrived to the general area in late July, just before dusk, and the team splits up. Art and I drive a back road, attempting to find the beetles using essentially his 14-year-old memories and a single phone pic of a tree on a hill that he'd taken near the original collection site. At this point, Art's getting pretty nervous. He's worried we're not in the right place and that we've all come out there for nothing. And then I look down and beetles, baby. And that wasn't it. We ended up finding quite a few more, even spotting some from our moving vehicles near a road cut on the way out. Many of them were chomping on grasshoppers, which was pretty cool. And Art was, needless to say, super relieved, but mostly he was just so excited to be a part of this funny little bug hunt. But that's the thing, we couldn't have done it without him and his daughter, without her teacher assigning that insect collection, without the generalist tendencies that drew me to entomology and Art and his daughter to bug hunting. Serendipity could be described as looking for something and finding something better along the way. As a generalist entomologist who's often criticized for being less than hyper-focused, I believe this is true, especially in a big undersurveyed state like Montana. Finding new things in groups other than those that you're specifically targeting requires knowing a little about a lot. Am I trying to defend against what some have called dilettantism? Yep, for sure. But broad-based observation is also the beginning of scientific inquiry. And I think luck often strikes us filthy generalists more often because while we might not know everything about a given group, We know enough to recognize when something is worth our time and attention. And I believe there's value in that. And thank you guys for your time and attention. That's all I have.
All right, and our next presenter is Josh Kulak with Imagining Insects and Exhibiting with Intent, Revitalizing a Dormant Entomological Collection at the North Museum of Nature and Science.
So in preparing for both ECN and ESA, I was debating between which presentation I was going to do where. And this is one of those guerrilla curating absolutely no resources story that just felt like it had to be Entomological Collections Network. I will say I am also presenting around living and non-living collections, and this is an area of particular passion for me. If anyone is interested in learning how insect zoos and museums can better collaborate, please talk to me. Spoiler alert, there are lots of new species hiding in plain sight. But let's get into the weeds of this kind of crazy collection. So in 2022, I, as an undergraduate student at Franklin Marshall College, get the opportunity to do a paid internship at this weird little museum on the corner of campus that is not affiliated with the college. I have never visited this museum, and I say, sure, why not? So a little bit of perspective, what I was used to going into this museum was the Academy of Natural Sciences of Drexel University, which you may or may not be familiar with, but it's, a 4 million specimen insect collection. It's got a dedicated entomology department with specialists. It's got a fully cataloged collection. Things are publicly searchable. Outside of educational collections, everything has data. I walked into a museum where it's, 300,000 specimens and objects. The insect collection, I can't give you a great number because it's not fully cataloged. And it's messy, but between 20,000 and 30,000 specimens, tiny. And one individual is in charge of all of the biological collections, all of the exhibits, the gift shop, and managing volunteers. Very different landscape. However, both institutions, the Academy particularly in training me and North in allowing me an opportunity to work with these specimens, have allowed me amazing chance to really grow my skills as someone who would like to pursue entomology once I graduate. So the other kind of crazy thing about this collection is a huge portion of it is 19th century material that has just been sitting. So there's stuff from Samuel Haldeman, who is cited by Darwin in The Origin of Species. Simon Snyder Rathbone is particularly interesting. He was actually a tailor, entirely a hobby entomologist, but incredibly meticulous in the way he pinned and arranged things. And one of the sort of both affirming and deeply depressing moments recently was reading this report from 1990 by Jordan Marsh, who I believe is now doing emerald ash borer stuff. Like, this job is going to be slow and long, but we need people doing it. So, and Rathbone's cabinet is shown on the right here. It is really remarkable, entirely self-articulated. And the reason that the specimens have persisted is largely because of his design and this cabinet. That being said, it has appeared in a few entomological publications here and there. There are a bunch from the 90s, or there are a bunch pre-2000, and then these are some of the post-2000 publications. But so I came into this as an intern. I didn't even know what I was looking at, what was in front of me. What I did come into the museum and find out is, okay, there are not nearly enough insects on display. This needs to be changed. So I come in, I do a little glass cabinet thing on insect taxonomy with some conservation and morphology thrown in. That spring, I do a drawer-by-drawer conservation analysis and assessment of this collection. Almost everything is on cork. What's not on cork is on sheets of foam, but the sheets of foam aren't actually attached to the drawer. They're placed on top of the cork. Extensive historic damage from dermestids, but no active infestations. But it's very clear that like this whole thing needs to be overhauled for the survival of the collection. It's also important to note that there is material with data. I would say the majority of it does not have data, but in the case of the Rathbone specimens, it's really interesting from a taxonomic history perspective because he's incorporating all of the new stuff he's getting from Haldeman, from Melshamer, from all of these 19th century people. So you are seeing very clearly how the taxonomy changes over the course of his lifetime. So going into the databasing, we're in FileMaker Pro. Thanks to Jordan Marsh and Alison Mallon in the 90s and early 2000s, there's some determinations in cataloging, but there are like different species with multiple numbers of specimens that refer to the same database number. There are some serious issues. Whole thing needs to be recatalogued. And 25% of this material is still not determined. None of it is digitized. So where to go from here? And somewhat ironically, the answer that I came upon and that my co-author, Molly, who supervised all this, came upon was the need for an exhibit. And the reason for that was, one, there is not really a collections budget. And two, if this is going to continue to exist in the museum, people need to A, know about it, and B, we need to engage the people of Lancaster, which everyone generally knows as Amish country, but is also actually one of the refugee resettlement capitals of the US. It's a really weird and interesting city with insects. So we decided, okay, we're going to do an exhibit. We're going to use that to really get the word out. We're going to try to get funding. We're going to get some initial Cornell drawers in the cheapest way we possibly can and go from there. So we start meeting with some donors. We do some of the initial, drafting around this. It is actually quite a large exhibit. There are false walls, which makes it seem bigger than it is, but still, we're talking 3 rooms, 3 reasonably large sized rooms. There were many gracious, everything was done in-house, all of our text, all of the design, all of the curation. I can say that I actually pinned into position every pinned insect in this exhibition. And there were also many gracious entomological reviewers, including some of you. I cannot thank you enough for that. And then we installed the entire thing in a few weeks in September. And unfortunately, my co-author broke their leg during part of that. So the install process was exciting, to say the least. And we have this exhibit now. It's going to be up for a year. And then hopefully that is going to propel things into actually getting to recurate and salvage this collection. So 4 colonies of live insects, 9 highlighted species of conservation concern. I was doing this as I was also running a study, which many of you have filled out. Thank you so much, around display efficacy and engaging people in biodiversity conservation. So I'm just coming in some days to Molly being like, no, we need to do something differently. We need to engage visitors in conservation more. So, also tons of Rikers. Dr. Adrian Smith generously provided some of his exhibit content. And we wanted to also have guides for kids on how to collect insects, on how to use iNaturalist, how to get data, but also information that is going to draw in adults around insects, raise awareness around insect decline, et cetera. So working with the text took a long, long time. Because it was really Molly and I and Jonathan Fantasier, who's one of the donors and supporters of this, and then our reviewers as well. So yeah, we did this exhibit. It's pretty cool. Should you find yourself in Lancaster? But it's also just been a remarkable experience for me in shifting my perspective a little bit. I am very much someone who, you know, I grew up with a fairly large natural history museum being the place that I was most comfortable. And so I very much pay attention to, you know, how many million specimens does this particular institution have? But there are thousands of specimens here with data, including there's some great 1920s Carabidae that just are in the dark. And this highlights this larger issue of there are so many regional collections, both in the US and worldwide, that are just not in these biodiversity databases. And there are tons of hidden gems that people need to be seeking out. And also just, while a lot of these specimens may not have data, that doesn't mean they can't have value in the context of education, in the context of outreach, and in the context of history. And paper archives have been particularly amazing on this front because there have been some specimens where I've been able to match Simon Snyder-Rathbone writing about it in one of his letters to the actual specimen, which is, it's an amazing feeling. And this is some of the unit trays are in the building, which they had not been previously for insects. So this is one of the first Carabidae and Cicindelidae drawers that we're working on recurating. Ton of acknowledgements. Huge thank you as well to ECN for funding my travel to this conference. It is incredibly helpful, especially as I'm graduating in December into the current economy. And just a huge thank you to everyone at the North Museum, to the folks who supported me doing this work at Franklin Marshall College, and also to everyone at the Academy who trained me. Thank you. And I think we have time for one question. Okay, thank you so much. Oh. I do not have a great answer to that. Can you repeat the question was how many, can you repeat the taxa? Ichneumonidae. And we do actually have a fairly large amount of Ichneumonidae. It's not, I mean, it's not tons, but it's at least, it's between 500 and 1,000. I have not determined them. They're on my list of things to determine, but I'm more comfortable with beetles. So at some point, if you're in the neighborhood, would love the help. Thank you.
Okay. Well, for our last talk of the afternoon, please welcome Max Barclay with Fighting Towards the Light, Keeping Collections Relevant in a Gathering Dark Age.
Excellent. Thank you very much, Chris. Excellent. Thank you, everybody. And it's lovely to be here again at the ECN, which is my favorite audience. We've heard about all the very, very interesting things that everybody's been doing. But today, I'm not going to be talking about very interesting things. I'm just going to be talking about general philosophical points, like I often talk about, that are inspired by the kind of talks and the kind of conversations that we have at the ECN. Now, I've called this Fighting Towards the Light, keeping our collections relevant in what I rather depressingly said might be a gathering dark age. I apologize for that slightly miserable sentiment. Entomology is a very peaceful profession, so it's surprising perhaps that this isn't even the first talk I've given at the ECN with the word fighting in the title. A couple of years ago, we had Fighting the Long Defeat, insect collections in an age of increasing relevance and decreasing recognition. We've got a new brand at the museum, so my slides are a slightly different color because the palette is different. But that's the slide from the first. This is a quotation from Tolkien, from Galadriel. Together, through the ages of the world, we have fought the long defeat. I can't give a talk without mentioning Tolkien a little bit in it. But the quotation, much that once was is lost, for none now live who remember it. To me, this summarizes the experience of being a natural history curator. You must remain optimistic and strive valiantly despite the growing threats to the natural world and to education and thought, which sometimes feel undefeatable. But we persist. With the destruction of natural habitats, the urgency to collect and document biodiversity constantly grows, and the relevance of natural history collections will only increase into the future. Quotation from Richard Fortey, who very sadly died last year. Collections are the conscience of the world. They show us not only what we have, but also what we've lost. Richard was a great science communicator and author of many books on the subject. And last year at the ECN, I briefly introduced the concept of Schrödinger's curator. Schrödinger's curator believes that specimens are so valuable, they shouldn't be sent out on loan, they shouldn't be digitized, they shouldn't be used for exhibition, they shouldn't be handled by visiting scientists because they're so precious. But at the same time, Schrödinger's curator believes that specimens are so worthless that we don't need more, we don't need to invest in infrastructure, we don't need to acquire new collections, we don't need to upgrade or improve our identifications. So Schrödinger's curator is the sort of hypothetical curator or administrator who is able to hold two completely incompatible sets of beliefs in their head at the same time. So a collection is valued into irrelevance. It's so precious that it's not useful. The result is that Schrödinger's museums just sit on their collections like a dragon on a pile of gold, not making them accessible. There's no increase in value, so it becomes more and more difficult to show the relevance or the importance of the collection. And sooner or later, somebody wants the space, or somebody wants the person power, or somebody wants the resources, and it's very, very difficult to defend a collection that hasn't been accessed and that hasn't been used and that hasn't generated anything. Of course, the solution is provided by a fellow American to yourselves, Joseph Grinnell, the director of vertebrate zoology at the University of California in 1910. He wrote a book, and he says a museum's policy should be everywhere as liberal regards the loaning of material to non-resident as well as nearby specialists. The value of a museum's hoard of specimens increases in direct ratio to the extent to which they are used. No museum is a success if it just remains a cold storage warehouse. So a good way to provide access, of course, is through digitization. The combined data labels of the world's natural history collections must be one of the largest unread scientific manuscripts in the world. And draw digitization of the NHM collection. The picture has disappeared from this slide, I'm sorry. It had a nice picture of a digitized drawer. But we've been digitizing our Coleoptera collections, and we've nearly finished. We're more than 90% through digitizing 27,000 drawers of Coleoptera and putting the drawers up on the web. We strive to digitize the collections because curators have more control and awareness of loss and damage. It facilitates offsite or remote working. It speeds all curation tasks. It raises the profile of the collection internationally and facilitates collaborations. And also, it allows many inquiries to be self-resolved. People want to write to me and say, do you have any specimens of X? They can just go and look on the data portal. What color is species Y? They can just go and look on the data portal. So a lot of routine trivial questions are being able to be self-resolved. But on the other hand, it generates a huge number of much more interesting questions, like the second specimen from the left in that drawer. You've misidentified that. That's a new state record. That's a new county record. That's a new country record. That kind of information, by putting the collection out there where the whole world can see it. But what has all this got to do with medieval monks, you might ask? Because my title was about medieval monks. And I was talking about medieval Europe when hundreds of monks and scribes, who are often the most educated people in their communities, were dedicating their lives to copying out classical manuscripts, duplicating and preserving them and making them accessible. It's only because of the efforts of these people that much of this ancient wisdom still survives. But despite this, the early medieval period is often referred to as the Dark Ages. This is because the classical works were usually accepted and copied without criticism or synthesis. An orthodox dogmatic culture lacked the mechanisms to question, innovate, and experiment, and ultimately learning stagnated. Replicating and preserving the knowledge of the past became a substitute for, instead of a supplement to, generating new knowledge. So we're talking about the monastic scriptoria, scriptorium singular, scriptoria plural. It's been described as one of the earliest examples of an assembly line, predating Adam Smith and Henry Ford by several hundred years. There were rows of monks copying out classical manuscripts and illustrating them in the margins at the same time. These scriptoria have been said that they preserved the knowledge of previous generations. They educated the monks in reading, writing, and illustration, as well as foreign languages. And they've been described as birthplaces of the arts, especially because of the elaborate illustrations in the margin. This is an illustration of somebody collecting a butterfly using a sword, not a technique that we usually use. But some of the extraordinary illustrations that you see in these margins are really quite remarkable, and some of them are entomological. So it all sounds fantastic. So why do we call it the Dark Ages? We call it the Dark Ages because the emphasis in this period of history was in reproducing and duplicating knowledge generated by the past without interpretation or without criticism. The demand was for reproduction and preservation rather than curiosity and innovation. This led to some strange phenomena. Knowledge suffers in repetition. Copying is not always complete, not always accurate. Errors get introduced and propagated. And information that is accessible is preferred over information that is properly verified. So once errors get introduced into widely used systems, they can reproduce there. So the process by which errors and inaccuracies were perpetuated in medieval bestiaries and in the scriptoria of the ancient monasteries is very similar to the process by which they are perpetuated by generative AI. Here are two pictures of a hedgehog. Now, I don't think you have hedgehogs here, but hedgehogs are a familiar thing in most of Europe, and they don't look like that. And they don't collect fruit on their spines. But every hedgehog in every medieval manuscript is collecting fruit on its spines because somebody once said that that's what hedgehogs do. So as far as everybody was concerned, that is what hedgehogs do. Here are some bees. With the classic wisdom, bees are the smallest of birds and are born from the bodies of oxen. Now, we all know that bees are the smallest of birds and that they look like that. And the legend that they're born out of the carcass of another animal, like an ox or a lion or so on, it goes back to the Bible and probably beyond. It's picked up by ancient Greek and ancient Roman writers. And there's this belief that flies swarming around a body might have been mistaken for bees, that a dried out carcass in the desert might be inhabited by wild bees, which are migrating or making a temporary hive. But these medieval works reproduce this information that bees hatch out of dead bodies again and again and again. And you can see that these bees have also got feathered wings like birds, and they've even got beaks like birds. Here are some pictures of ants. All of these ants have got 8 legs. One of them is as big as a person. I think that these monks and scribes can be forgiven for manticores and dragons and even lions and tigers, because these people didn't have access to those animals. But they could have gone out into the garden of the monastery and they could have seen a bee and they could have seen that it doesn't look like that. And they could have established that the hedgehogs that were all around them were not picking up fruit on their spines. But there was a general lack of questioning. There are parallels with today's AI discussions from this morning. There was a quotation from Chris Johnson's lecture that once an error is accepted as correct, it then gets added in and it propagates itself. And this is what we see happening as well with the medieval scriptoria. All over Europe, people were copying out the same pseudo-facts and pseudo-errors. Of course, the monasteries, unfortunately, in England came to an unfortunate end in the 1530s because Henry VIII decided to close them all down and realize their assets. And that involved the so-called dissolution of the monasteries. This was prompted because he wanted to divorce his Catholic wife, Catherine of Aragon, and the Pope said no. So he said, well, we're not going to have anything to do with the Pope, and we're not going to be Catholics in this country any longer. So basically, because one individual leader wanted to have a divorce, he changed the religion of the whole country. And a beneficial side effect of this, from his point of view, is that he could close down all the Catholic monasteries and steal all their money, which is obviously a threat that hangs over most academic and scientific institutions, that somebody one day might want to close us down and steal all our money. There are surprising convergences between the uncritical acceptance of the work of classical writers by medieval monastic scribes and the uncritical acceptance of AI in our modern world. The same goes for the products of digitization. We need to be wary of returning to a culture where information is uncritically accepted because the emphasis was just on providing answers rather than providing correct answers. An appeal to authority should not be prioritized over actual discovery. It's interesting that just recently, I've talked about Dark Ages. The term Dark Ages has fallen into disfavor among some historians. One wonders why nowadays we should be so polite about an era of declining intellectual innovation and uncritical appeal to authority. Suddenly we're supposed to be complimentary about that kind of culture. So things to think about. Financial and institutional support for digitization is currently much easier to get than is funding for the kind of work that produced the specimens and identifications that we're digitizing in the first place. That's interesting. One wonders why that is. One instinctively might at first think that it's because the skill level required for digitization is lower, and therefore it's more digestible than actually doing the taxonomy and actually describing the species and building the collections. But I don't think that that's the answer. Two similar quotations set apart by thousands of years. Apologies to Mike Farrow for quoting him in the same slide as the Bible, but Ecclesiastes 12:12, of making many books there is no end, and much study is a weariness of the flesh. And a quote from Mike Farrow 10 years ago, discovery and exploration of the natural world is part of the human condition. Exploration, along with sports, music, and art, belongs to a class of human activities that represent endeavors without end. So the thing that those two quotations have in common is this concept of endlessness or open-endedness. Perhaps the whole open-endedness of biodiversity exploration and discovery is what makes it seem overwhelming and off-putting to funders and administrators. Perhaps they prefer something clearly defined with an absolute start, middle, and end. But we do need to make sure that our collections don't become relics of a forgotten age, products of a lost art, that we no longer understand that we've lost the skills to develop or interpret. This is the paradox or the crisis of Galadriel in the Lord of the Rings. You are fighting the long defeat. You are fighting to preserve something that is no longer understood and that doesn't have a future. And that's what we need to guard against. Or else we risk opening the door to our own irrelevance. And I had to put that postcard up because I picked it up outside and it was fantastic. No one on their deathbed ever says, I wish I'd worked more, except entomologists. Thank you very much. Have we got time for any questions or comments or throwing vegetables? No comments? Oh, yeah.
When I was a child and my parents saw this newspaper ad about joining naturalist clubs to see other kids who I didn't have in school to do. The leaders of the clubs were old Catholic priests who were, of course, taking us to fossil beds and so talking about evolution and everything. So they had very different from these dogmatic ones. So I owe them a lot. They were really, really very knowledgeable and great communicators. So.
That's a question from Luc LeBlanc about Catholic priests showing him fossil sections and helping him to develop as a scientist. Excellent. Yes. Doug.
Once a bad idea is in place, I'm not going to
many more people recognize data. There's a lot of things that are pretty awesome. And then we have resources like Wikipedia, which gets cited and drawn from by all sorts of other places. And if the information in Wikipedia is wrong, then it gets protected. We can do something about that too. Take some of our own responsibility.
That's Doug saying that we all have a responsibility to correct errors in iNaturalist and Wikipedia and other things, because once an error is established in those platforms, it's very difficult to root it out and you need a lot of people. I think that's absolutely right. I always think of an error in iNaturalist or Wikipedia. I think of it like a piece of glass on the beach. You know, that once you see it, you have a responsibility to take it away. Otherwise, it's going to hurt somebody else. And so I always try and fix those things when I see them. But it is, of course, an endless process because there's a lot of misidentifications in iNaturalist. I think iNaturalist is pretty good at having a lot of people going over it. But maybe we should all remember that in order for it to be such a wonderful resource as it obviously is, we have to keep the identifications correct and up to date. Deborah. Matt.
Some discussion in the AI world that they basically assumed all of the information as digital and everything is assumed already. And there's going to be a need for new information. And this need for information, new information, may drive us back into sort of a Renaissance period where experts like those in this room are very valued because they are the only ones that are available to get new facts. This is thought come across like there's a lot of burn down where the big companies are showing they've digitized everything in the world. They've absorbed everything. I have colleagues now that work with Wolfram, and they're generating all these new data. They're getting paid generating new data for chemical formulas. It seems very mundane.
And is it going somewhere where AI can scrape it off and
already? This idea that maybe this will drive us back into spending money on new facts.
so can we get something like the Renaissance patrons who are supporting the artists and the sculptors of the Renaissance, and we get AI generators who are paying people to do science so that the science can be scraped up by the AI? So they've already consumed everything and they're desperate to differentiate. Yeah, that sounds very exciting. I'm sure there's people in this room who are already well onto that and are probably thinking, oh, damn, other people are getting the idea as well. But
Now, I'm reading about companies assuming everything, thinking about what.
I think it's a very interesting idea to see that the AI companies have consumed everything and are actually going to be hungry for more information. And that the only people who can provide that information are the kind of people who are in this room. That's really interesting, actually. I don't know whether it's true or not, but I hope it is. I think we need another Renaissance rather than another Dark Ages. I think that would be good. Excellent. Thank you.
Thank you, Max. All right, we now have a break before our business meeting, and that will be back here at 5:45. Again, I'd like to thank all the presenters from today. Wonderful slate of talks. Stay tuned for the business meeting because we'll have tokens for drink ticket reception.